Hey guys, welcome to this session on Amazon Web Services. Amazon Web Services is the leader of the cloud industry. But how did they become this indisputable cloud leader? They provided scalable and reliable cloud services, and you just have to pay for what you have used. To state a fact, Netflix, one of the largest media service provider, has its entire architecture hosted on AWS. And in this session, we'll be learning AWS end to end. So before moving on with the session, please subscribe to our channel so that you don't miss our upcoming videos. And right now, let us take a quick glance at the agenda. To start off with, let us quickly brief our cloud computing fundamentals. And after that, we'll be looking into what is AWS and why do we need AWS. And after that, we'll look at various services provided by AWS. And after learning all these services, we will learn how to architect an entire website or an application using AWS. And we know that Lambda is one of the most used AWS services, so we'll have a dedicated hands-on for that and also learn a lot deeper into that particular topic. And also at the end of this video, we have a set of interview questions and with detailed answers for any people who want to crack an AWS Solutions Architect interview. And also, this video covers most of the AWS services, but still to become a professional AWS Solutions Architect, you need to put much more effort, and also you need to take up a professional course. And I would suggest you to take up an professional AWS Solutions Architect course provided by Intellipaat. So check out those details in the description. And right now, let us move on with the session.
To start this with, before the rise of cloud. So what was the approach to run an application on the internet before cloud? How do they run it? How were they running it? Let me give you a brief with that. So the first thing a company does is they buy stacks of servers and hardware components. The second thing is they have to maintain and upgrade the servers and databases and the hardware components according to their needs. Then they have to keep on monitoring and reporting it. They have to have reports in order to upgrade or downgrade the softwares and the hardware. And finally, they have to consider traffic of their applications or their websites in order to scale. Then finally, they have to recruit top security professionals so that they can handle incoming unauthorized accesses and threats. It sounds tiring, right? Okay, now let me tell you what are the disadvantages of on-premise setup. The first disadvantage is maintenance of servers. To maintain servers, you always need professionals who can maintain the servers 24/7. Then there will be an increase in expenditure every time you upgrade your hardware, because in an on-premise setup, most of the time when your websites or applications traffic goes down, your hardware components will be idle. When they are idle, it is total waste of money and total waste of time to have those many hardware components. And also it increases your expenditure because you have to maintain all of the hardware components which are not even in use. Then data privacy and security is poor, because whole data privacy and security system and the control is in your hand. The company has to provide data privacy and security. It's not going to be in a third party's hand, it is going to be in the same company's hand. Then scalability and flexibility. So what is scalability is that when the traffic goes higher or down, it should automatically or manually scale up or down according to the needs. But in an on-premise setup, scaling up is very easy, but scaling down is not that easy. Okay, now moving on. Let me introduce you to cloud computing. Let me first tell you what is cloud computing, then I'll give you more explanations on its advantages. So in the simplest terms, cloud computing is a technology where a resource is provided as a service through the internet to a user. It can be anything. For example, Google provides Google Docs, Google Sheets through the internet. And it is a software which is provided through the cloud, and that softwares are hosted in Google's personal cloud platform, which is GCP, Google Cloud Platform. Okay, now moving on to the cloud computing benefits. The first benefit is better data privacy and security. AWS or any other cloud provider like Azure or Google Cloud Platform will always hire top security professionals because they have their own products running on their cloud servers. Second is no maintenance worries. You just have to pay the subscription fee or the money which you are going to take for the particular services. You don't need to worry about maintenance of those hardwares. All of the maintenance will be taken care by the cloud providers. Third is faster data recovery. You can store your data in multiple points, like you can store your data in US and UK. So when your main service data or main database data is lost, you can take the data from some other location and recover it even faster than you expect. The fourth point is scale dynamically. So scale dynamically is very simple. It is auto scaling. That means whenever your websites or applications traffic increase, the system automatically scales up your hardware components. And when the traffic goes down, it scales down your hardware components. And you just have to pay for the particular hardware components which are running currently. Then finally, reduced costs. All the businesses needs to reduce their costs. They always want to cut expenses. So using a cloud provider or using the cloud computing technology makes it very easy so that they can cut maintenance costs, they can cut cost of security professionals, and also the scaling process is seamlessly very easy.
Okay guys, a quick info. If you want to become a professional AWS Solutions Architect, you can take up this AWS Solutions Architect course provided by Intellipaat. In this course, you will be learning all the concepts which is required to crack the AWS certification exam. And also there are 3 major projects involved for you to understand it better. Now let us continue with the session.
So next is, what is AWS? We all know that AWS is a cloud computing platform. That is, AWS Amazon Web Services is a cloud provider which provides a lot of services on the internet to the user. Many companies like Netflix, Unilever, Expedia are using Amazon Web Services for their own personal needs. Netflix have went all into AWS. That means all of their infrastructure right now depends on AWS. So think of AWS's capability. Now let me give you a few examples of other cloud providers. The first one is Microsoft Azure. Azure is owned by Microsoft and they also host their own products on it, like Office 365, and also you can do native integration of IDEs like Xcode, IntelliJ IDEA and Visual Studio. Then Google Cloud. We all know Google is the biggest brand name in the internet industry. Google Cloud came around 2011 and it has become a hit, and it is now the third most popular cloud provider in the world. Alibaba Cloud. We all know Alibaba. Alibaba is a China-based company. Alibaba Cloud is also called as Aliyun. It basically provides services to businesses who want to host their services online. Next is IBM Cloud. IBM Cloud is also similar to Azure, Google Cloud and Amazon Web Services. It also provides services like compute, networking and storage services. Then comes VMware. VMware is a software virtualization company. So basically they provide virtual machines via the internet to users or companies. Finally, Salesforce. Salesforce is also a cloud platform and their main tool is CRM, that is Customer Resource Management, and they are considered to be the number one at it. So why is Amazon Web Services so successful? They have started AWS in the year 2006 and it is still the number one cloud platform. Let us see why. Before even a cloud company thought of it, Amazon Web Services already revolutionized the IT industry by introducing a new way to use servers to the companies and the businesses. And there are 3 key points which made AWS successful. The first is it's simple and per hour billing. The billing system of AWS is very simple, that you will be only charged for the particular services which you use, and it is also based on the number of hours you use, not the days or the months. The second reason is Amazon's brand name. Amazon.com is a household name all over the globe because it is the biggest e-commerce platform. Third reason is its easy profile setup. The first thing you have to do is provide your details, your email address, your username and password, just like you create a social media profile. And the second step is you have to give your credit or debit card details, and that's it. Your AWS profile has been set up. But what makes Amazon or Amazon Web Services peculiar? So Amazon has its own leadership principles and it makes its employees follow that. Let me give you a few examples of them. The first is customer obsession. Customer obsession is that leaders start with the customer and work backwards. The first thing they follow is they need the customer's wants. That means whatever the customer wants, they want to give. Then they work backwards, they reverse engineer. The second is invent and simplify. Leaders expect and require innovation and invention from their teams and always finds way to simplify. They also need inventions and also they need to simplify it. The simplified, most easiest user-friendly manner is more attractive for a customer. Third principle is ownership. Leaders or owners, all the employees in AWS or Amazon need to have that feeling of ownership. And the fourth point, this point is common for anybody. So learn and be curious. Leaders are never done learning and always seek to improve themselves. So always keep on learning and be curious in what you do. The next is the future of AWS. So what is going to be the future scope and the job trends of AWS? Let us see. So the market share of 2018's quarter 4, that is the last 3 months of 2018, Amazon Web Services had 32.3% of the cloud computing share, and Microsoft Azure comes second with 16.5, which is almost the half of Amazon Web Services, and then Google Cloud Platform, and then Alibaba Cloud, and after that comes the other services, other cloud providers like IBM Cloud, VMware, and Salesforce. And what are the AWS job trends right now? Let me give you few job trends. So the 4 job trends are AWS SysOps Administrator, Cloud Developer, AWS Solutions Architect, Cloud Software Engineer. So the salary of AWS SysOps Administrator is $111,000 to $160,000, and the Cloud Developer is $95,000, and an AWS Solutions Architect salary varies from $98,000 to $150,000, and a Cloud Software Engineers varies from $63,000 to $93,000, and these are all the numbers for a fresher. The salaries may vary with your experience. If you are an experienced person in the cloud industry or in AWS, you might be earning more than this. This is just the starting.
Moving forward, guys, now let's talk about the thing that we are here to learn for. Let's talk about the AWS services. Let's see what kind of domains does AWS gives its service into. So AWS provides its services in compute, it gives in storage, database, security, management, customer engagement, app integration, etc. So we're going to discuss each one of them one by one as we move along. So first up, the compute domain or the AWS domain is compute. Alright, so I think I have a question from Shubham. So Shubham is asking me, among these domains, what is the difference between storage and database? Alright Shubham, so storage is basically used when you have a workload wherein you want to upload binary files. Like what are binary files? Files which like video files or MP3 files or photo files. All these files are called binary files because they're not data. It's basically, it's content, and that content is basically binary in nature. All right. So all your videos, all your music, right? Any kind of file which you execute, your games, all of those are binary files. When you compare it with database usually deals with data which is textual in nature and has a proper structure. It could be unstructured as well, but basically textual data that a human can read is included inside a database, right? But on the other hand, files that run on computer, for example, any program or any video file, any music file, or any other file in that case, these kind of things cannot or should be stored on a storage kind of platform. It should not be stored on a database. It can be, but it should not be, because it unnecessarily makes the database, the size of the database big, which actually causes a problem when you're querying through the data when you're using a database. Alright, so guys, this is the difference between storage and database. Shubham, is your doubt clear about what the difference between storage and database? Alright, so I've got a yes from Shubham. Others, guys, if you have any doubts in these domains, you can ask me. Let me explain you all these domains one by one. So compute domain basically deals with servers. So if you have, if you need servers, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. More on this we'll discuss as we move along. All right. Then we have the storage domain, which, like I said, deals with storing binary files on the remote servers. So for that, we have a dedicated services, and we're going to discuss those dedicated services in storage. Then we have a service called database, a domain called database. In the database domain, you have a lot of services. So if you have structured data, you have one kind of database for that, or you have one kind of database service for that. If you have unstructured data, you have another database service for that. So we'll discuss more on that as we move along. Then there is a domain called security. So all security related to the application that you have uploaded, to the servers that you are using, to the account that you are using. For all those kind of things would be included in security. So there are specific services for each kind of workload that I just mentioned. We're going to discuss that when we reach the security domain. Then we have the management domain, which would include monitoring, which would include deploying the whole architecture at once, right? All those kind of services comes in management. Don't worry if you don't understand it. I'll explain you more as we move along in that domain. Then we have customer engagement. So sending emails, sending notifications, all those kind of services comes under customer engagement. And in the end, we have app integration. So services like queues, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you'll store all your jobs, and that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integrations, and we'll be discussing the services in that domain as we move along. All right. So guys, these were the domains, the main domains that are there in AWS. There are a lot of other domains as well, but we'll be focusing more on these domains since, this is what is actually going to be asked for in your solutions architect exam. And at the same time, these are what you will generally be using when you become an AWS engineer. All right. So moving forward, guys, now let's start with the compute domain and let's see what all services are there in the compute domain.
Okay guys, a quick info. If you want to become a professional AWS Solutions Architect, you can take up this AWS Solutions Architect course provided by Intellipaat. In this course, you will be learning all the concepts which is required to crack the AWS certification exam. And also there are 3 major projects involved for you to understand it better. Now let us continue with the session.
Alright guys, so let's discuss the AWS services in the compute domain. So here are the set of services which are included in the compute domain of AWS. So this particular service is EC2, Elastic Beanstalk, Lambda, Autoscaling, AWS Load Balancer, AWS ECR, and AWS ECS. Now for the sake of explaining you guys, I've taken the liberty of shifting some services from some other domains which I think should fit in this domain, right? But you don't have to worry, the explanation would be the same. It's just that you would find it somewhere else in the AWS management console. Like for example, autoscaling would not be under the compute domain, it would be under some other domain. I'll show you when we move on to the AWS management console as to where you can find each and every service. For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch, and what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well. Right? So guys, Elastic Cloud Compute, like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything. You can make it anything. You can basically build it, make it a web server. You can make it a database server. It can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of creating a EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance, so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also do that, right? Let's say if my RAM was 8 GB over here and then I want to make it 16 GB, even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, that is EC2, right? Our next service is Elastic Beanstalk. Now Elastic Beanstalk, guys, is an advanced version of EC2. How is it an advanced version of EC2? In EC2, what you could do was you could just launch a server, right? And then you can install softwares on it. You can make it a database server. You can make it a web server. You can make it anything, right? With Elastic Beanstalk, you get certain restrictions on EC2 and there is a certain amount of automation involved. So what is Elastic Beanstalk exactly? Elastic Beanstalk basically is a web application server, right? You cannot install any other software on it. It is a web application server on which you can upload your website and you don't have to install any software. You don't have to do anything. Like I said, we talked about what is infrastructure as a service and what is platform as a service, right? So infrastructure as a service is EC2, okay, where you get the whole server, you get the access to the operating system, etc. Elastic Beanstalk is platform as a service. So in this, what you get is a dashboard. You don't get access to the operating system. You don't get access to the softwares that you have to install on that server, right? Everything is pre-configured. All you do is you say that I need a PHP server. It'll launch a PHP server and it'll give you a dashboard where you'll have a upload kind of a button. You click on that upload button and you'll have to put or upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go. And all you have to now do is just go to that IP address or the domain name of that particular Elastic Beanstalk instance, and you will be able to access your website. If you compare it with if the same thing you had to do on EC2, you'll have to first install the softwares, then you'll have to upload the file using FTP because there's no dashboard to upload it. So you'll have to download an FTP client, connect to the instance, upload your files like that in that particular folder. And then if you go onto the IP address of the EC2, only then you'll be able to access the website. With Elastic Beanstalk, what they did was, like, if you have a use case where you have to deploy a web application, you don't have to do all that manual stuff of installing the software, of installing or putting your files on the server. All you have to do is you have to open Elastic Beanstalk, select the environment that you want to deploy, and upload your website over there. That's it, right? So it's an automated version of EC2 in which you have certain functionalities of putting a website over there, but there is a limitation that only it can be a web application server, right? It cannot be a backend server for you. Elastic Beanstalk is only used to deploy your websites. Guys, remember that. Because the next service of ours is a little different from Elastic Beanstalk, right? And it also has some limitations. Our next service is AWS Lambda. Now, AWS Lambda, again, guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now, what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image. And what that website does is it stores the image on its storage and then it reduces the size of the image, right? And then you can download it again. Now, you might be wondering, this is one website, so ideally everything should be happening on one server in this case. But that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result on the website. So basically only processing happens on AWS Lambda, only website deployment happens on Elastic Beanstalk, right? And AWS gave us these two wonderful services so that we can create a distributed kind of an architecture wherein, there is no fault. If there's a fault in one server, it's not like my whole application will go down. I have certain redundancies in place. I have distributed my work among multiple computer nodes so that even if one gets faulty, it's not like my application will go down. We'll discuss more on this as we move along and we talk about auto scaling. But guys, remember this, AWS Lambda is only used to run your background code. AWS Elastic Beanstalk is only used to deploy a web application. EC2 can be used for anything. It's your own private computer. You can install any software, make it a backend server, make it a web application server, make it a database server for that matter. Do anything with it, right? That is what AWS EC2 is. Now, if you see the diagram over here, as you can see that, let's say there's an e-commerce application, right? And that e-commerce application, there's a trigger for basically buying something. Let's say you order a package, right? So when you order a package, what happens on Amazon? That entry is made into the database. So that entry is stored, let's say, in DynamoDB, which is a kind of database in AWS, right? Now what happens? Now, once the data is stored in DynamoDB, you want to do some processing on that data and then go ahead and store it somewhere else, right? So once the data has been stored in DynamoDB, I need the processing to be done. Now, the one way to do it is you do everything on the same server, where basically, let's say my package order confirmation happened on the web application, right? The web application server triggered this particular action that I have, my package order is confirmed. And that's when it issued a command to store the data in DynamoDB. That is all done by my web application server. Now I can also, this server itself can also do the processing for DynamoDB and then store it on Redshift warehouse. But the processing takes a lot of time. And that is the reason I differentiate my processing on a different server, or I make my processing happen on a different server so that there is no overhead on my website, so that my website is not becoming slow irrespective of the fact that what kind of workload is running in my backend, because that workload is being managed by AWS Lambda, right? So my website can be up and running. It will always be available to all the users irrespective of the fact how huge of processing I have to do, right? So that happens by AWS Lambda. One more thing, guys, one more cool thing about AWS Lambda is that whatever job you give to AWS Lambda, it's not one server which does the job. AWS Lambda takes a job, executes it in one server. If it gets one more job in the meanwhile, what it does is it launches a second server on which that job will be executed. Similarly, if there's a third job which is coming, it will be executed on a third AWS Lambda server. So that's how it works, right? And once the processing is done, it can also give the communication back to the web application, and that's how you get the message that the operation is done. But what you don't understand is how many computers or how many servers are working in the backend, right? So now you know. So AWS Lambda, wrapping up, guys. So AWS Lambda is used for executing a backend code. AWS Elastic Beanstalk is used to deploy a web application. And AWS EC2 is a raw server which you can use to make that server anything, right? It could be a web application, it could be a backend server, it could be a database server, etc.
Okay guys, a quick info. If you want to become a professional AWS Solutions Architect, you can take up this AWS Solutions Architect course provided by Intellipaat. In this course, you will be learning all the concepts which is required to crack the AWS certification exam. And also there are 3 major projects involved for you to understand it better. Now let us continue with the session.
Our next service, guys, is load balancing. Now, what is load balancing basically, and why do we need this kind of a service? Now, guys, I told you that whenever we create a production grade application, we basically deal with distributed computing, right? So when we talk about distributed computing, we also have to talk about redundancies so that my application is highly available. Now, what does that mean? Imagine these three servers are your web application servers. Now, if you just had one, imagine you just had one. In that case, what will happen? If there is any kind of fault in this particular server, my application will go down, right? So what I do, I launch 3 exact copies of that server, right? And what happens in that case is, if this server goes down, my user can view my website on this server. If both these servers goes down, my website can be viewed on this particular server, right? But now you might be wondering, how will the user know which server to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is, it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is, it will stop routing traffic to that particular server, right? And it'll start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the 3 servers are functioning in the healthy state, in what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is, it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Autoscaling. So what is AWS Autoscaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach autoscaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. And the load balancer should now route the traffic to the new instance as well, right? So this is what autoscaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is, at the moment the collective CPU usage goes below 40%, it will decrease the number of instances in your autoscaling group, right? And that's how it works, guys. And the autoscaling service cannot exist alone. It always has to work in conjunction with AWS Load Balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of autoscaling, you will always make use of AWS Load Balancer. On the other hand, you can just make use of AWS Load Balancer and you might not want to use autoscaling. That is fine. But if you're using autoscaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what autoscaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application, right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry guys if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now if you want to run those images, you have a service called ECS. So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now don't get confused guys with what we do in EC2. Now you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case, what will happen is you're still the machine on which the containers are running. That becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an auto-scaling infrastructure. That is a machine on which Docker is running. But if the processing or if the CPU gets an overhead, and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know guys what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS. Alright guys, so moving forward now, let's go ahead and do some hands-on. I think it's enough of theory for compute. Let's go ahead and launch some compute instances in AWS. Alright, so what I'm going to do is, let me first show you how you can create your account on AWS first. So let me just jump on to my browser. Alright guys, so the first thing that you would be doing is heading on to aws.amazon.com. Okay, so once you are on this website, you will see a big orange button over here which says create an AWS account, right? Just click on that and that will take you to the next screen wherein you will have to fill out your details. So fill out all your details over here, right? And once you have done that, let us enter some pseudo values. So let's say it's abc@intellipaat.com. Password, I can set anything over here. Similarly, I'll set anything over here. AWS account name, let's say it's Intellipaat -test, right? We'll click on continue. Then it will ask you what is the account type? Is it a professional account or it is a personal account? So we'll select personal account because we are just trying out AWS, right? So we want to use it for ourselves. Give some number. Let's say I give 1 2 3 4 5 6 7 8 9, and the country or region, you can select any region that you are in. Your address, the city that you are in, postal code. So let's say the city is Bangalore. State, let's say it's Karnataka. And once everything seems fine to you, just click create account and continue. Once you do this, you will reach this screen where you'll have to enter your debit card number or credit card number, right? Enter everything over here and click on secure submit. Once you've done that, the next page will ask you what kind of account do you want to create. Is it a business account or a standalone account? What purpose will you use this account for? Just, it's all logical. You just know what you have to answer. Just remember this, you are creating a personal account and it's nowhere related to a business. Select everything, click on finish, and you will have a new AWS account created for you. Now, one awesome thing about AWS, guys, is that it will give you free tier. That is, you can launch instances free for 1 year, right? And every account that you create on AWS, or when you sign up on AWS, you'll get a 1 year free tier account where you can launch a certain EC2 instance for free, and that too for 750 hours a month. So 750 hours is actually 30 days, and that too for 1 year, right? So 1 year of free instances you can launch. So I'll show you guys how you can launch instances as well, but this is how you can sign up for AWS. So once you have signed up for AWS, guys, next thing would be to basically log in, right? And for that, you'll have to, once you go to aws.amazon.com, just click on AWS Management Console and it'll take you to the sign-in page. Okay. So on the sign-in page, just enter the email address that through which you want to connect. 1 second, guys. So this would be the email address that I want to enter, followed by the password, and this will make you sign in into AWS. So this is a step that you should reach once you have completed your sign up. Okay. And now what I want to do is I want to launch my first server on AWS. Now, how will I do that? So we have studied about the EC2 instance, right? So for launching the EC2 instance, here is the domain. So the domain that we went through was compute. Right? So in compute, you have these many services. You have EC2, ECR, ECS, then you have Lambda, Elastic Beanstalk. There are other services as well. We have not touched those services because they would go beyond the scope of what we intend to do in this session. This session is an overview for AWS, for an AWS solutions architect, right? So the services that we have picked up, they're all the basic services that you should know about. And once you understand all those services, understanding the rest of AWS would be a cakewalk for you, right? So there are so many services in AWS. You have Ground Station, Security Hub, Artifact. If you're into game development, then you have Amazon Game Lift. But all these services are basically confined to a certain kind of work that you want to do. Like, I am not going to develop a game, right? Or I'm not into gaming, or I'm not into game development. So this service is not for me. Similarly, there are IoT services that you have to know of, but IoT, not every company would use IoT, correct? Some companies would use IoT, and for you to learn the IoT service, it would be a waste of time for you, right? And that is why what we have done is we have picked up some services which are essential and which most of the organizations will use who are into IT and want their application up and ready. And we have just selected those applications, right? Or those services. Also, your AWS Solutions Architect exam would be confined to only these services that we are learning. All right. Now, what we wanted to do was we want to launch our first server, and for that, there is a service called EC2. So either you can find it under the domain compute, that is EC2 over here, or you also have an awesome option over here to search for any kind of service. Let's say I want to launch or I want to go to EC2. So I can just write EC2 in the search bar and I will get the respective result over here. Let's click on that. And now this link would basically open your EC2 dashboard. Right? So from here, you can launch your first EC2 instance. There are a lot of options on the left, guys. Do not worry about each of these options. These are options that we will be studying about when we purposefully just talk about EC2 service, and that will be in the further sessions that we're going to have. For now, just understand how to launch an EC2 instance. And for that, you just have to click on this blue button, which is here, which says launch instance. Just click on that. Once you've clicked on launch instance, you will get an option to select the operating system that you want to run in your server, right? So there are a lot of operating systems to choose from. You have the Amazon Linux AMI, which is a custom Linux that AWS has created. Then you have Red Hat OS that you can run. you have SUSE Linux, you have Ubuntu. There are a host of operating systems that you can run from. You have Windows as well, right? So you choose whichever you want, and always ensure you choose an operating system which says free tier eligible, which would mean that it will fall under the free tier and it will not be charged for you. Okay, so let's say I select the Ubuntu server. I'll click on select, and now it will ask me what is the size of the server that you want. How much of CPUs do you want? How much of memory do you want? So the only server, so there are a lot of options over here to choose from, right? But the only server that is free for you would be T2.micro, okay, which has 1 CPU and 1 GB of RAM, which is enough for demo purposes when you want to try out AWS. Okay, so you would select T2.micro if you want to be under the free tier and not be charged. So just select T2.micro. Next, you will click on next, and then it will ask you for all the details that are over here. Do not worry about anything, just leave them blank. Click on next. Next step would ask you for the hard drive storage. How much of hard drive storage do you want? So by default it's 8 GB when you're launching a Linux instance, so we leave it at default. If you want, you can change this, right? Then click on next. You can add tags over here. What are tags? Tags are nothing but metadata to your instance, right? Like for example, I can say the name. I can add a tag that the name of the instance is something, then the department to which this instance belongs to is there. So all those values I can write over here, and those will serve as a metadata for the instance, so that when somebody is searching for all the EC2 instances for, let's say, the IT department, they just have to type in department equal to IT and it will list all the instances. So for those kind of searches, you have tags. Click on next, then it will give you the option of configuring your security group. What is a security group? It's nothing but a firewall. It's a very simple firewall, guys. In this, what you have to tell is, so basically all these rules that you can add over here, these are all inbound rules, right? So inbound means what kind of connections are allowed on this server. So there's a SSH connection which is allowed, right? So you can select the protocol that you want to allow on this server, right? So right now, what has been allowed is the SSH protocol, so that we can log into this server. SSH means that, right? If you select SSH, it will fill out all the details for protocol and port range by itself. Now, whom do you want the SSH protocol to be used by, right? If you want it to be accessed by anyone, you can just give anywhere. Why is this option helpful? This option is helpful when the IP address of your computer is not fixed. Let's say you can access this instance from office, but you also wanted to access it from home as well, right? So if you want to access it from home, then you have to select anywhere. If your IP address is not changing, you can select my IP, right? Let's say this is my IP address right now, and only I will be allowed to connect to this instance using the SSH protocol. But it's the generic use case that everyone deals with is that they want to log in from anywhere, right? So I'll select anywhere. It fills the data by itself. And now finally, I can just click on review and launch. So if you want to delete a rule, guys, since in this rule I did not define anything, I can just delete this from here. And now let me click on review and launch. Okay, so now I can review all the settings that I've done. Once I feel everything is correct, I'll just click on launch. And this is a very important step, guys. Now, to log into any server which is there on the remote system, imagine like if somebody gets your IP address, anybody can access that server and they can make any change that they want, right? But it's obviously not like there's a security layer that we add, or which AWS has added to the servers that it launches. It gives you a key pair, right? What is a key pair? A key pair is nothing but it will give you a key that you will have to use while you're connecting to the instance. Okay, so as you can see, there's no key pair right now. So what I can do is I can create a new key pair. Let's name this key pair as, let's say, test-Intellipaat. Let's say this is the name, correct? I will click on download key pair. So unless I don't create a new key pair, this launch instance button will not be active. So this will download a PEM file for you. This is a file which is of the PEM extension, right? So this will be used to connect to our instance. And finally, when everything is set, let's click on launch instance. So now you can see your instances are now being launched. This is the message that you're getting. So I can just go to the instance and see that, okay, so there's an instance being launched. The instance state is pending, which means it's still in the launch process. I can give this instance a name. Let's call it test. Okay, and now it's in the running state. Great. So now once you have selected test, you can refer to all the details of test in the below panel. So here is the IP address which will be used to connect to it, right? The instance type, which is t2.micro, the state, which is running, right? Then you have the security group. So view inbound rules, you can see there's a SSH rule that you have added over here, right? And then the next step would be that what is the key pair name for this instance? It's test Intellipaat, so on and so forth, right? Now that you have launched the instance, the next step is to connect to it. Now, when you want to connect to this instance, there's a software called Putty that you can download, right? So here's a software that I've already downloaded. If you want to download this, just search on Google for download Putty. You will get this link. Go to this link, right? Now guys, there are two things that you have to download. One is you have to download Putty, which you can use by clicking on this link. It will take you on this page. Just select, if you're on Windows, just select Putty 64-bit. Just click on it and it'll basically download the Putty software for you. The other thing that you'll have to download is Putty Gen, right? This is also required. I'll tell you why it is required. So this is basically Putty Gen, and the other software that you need is Putty. Okay. So once you have both the softwares in place and you have installed both the softwares, next step would be to connect to our instance. So this software of mine is Putty Gen. Let me launch it for you. This is Putty Gen, guys. The PEM file that you get, guys, if you have to use it with Putty, the way you can use it is by converting this PEM file first to PPK, because that is what your Putty software would accept, right? So first I'll have to load this file on my Putty Gen. So let us do that. So I'll click on load and then I'll select the PEM file, which is this. It says successfully imported. Great. Now I want to save the private key. If I save the private key over here, it will ask you, are you sure you want to save this key without a passphrase? Yes, right? And let's name this private key something. Let's name it, let's say, test. So as you can see, the format now is being changed to PPK. Great. Let's save the file. The file has been saved. Next step is launch your Putty software. Right, this is my Putty software. The instance that I want to connect is this. This is the IP address that I want to connect to. I'll mention it over here. Then I'll go to SSH. Because I've mentioned the IP address in the session part, now I also have to put the key using which I will connect, right? So for putting the key, you have to go into SSH. Then you'll be clicking on auth. In auth, I have to select the PPK file which I created. So this is the file, test. Let's select that and let's click on open. So now it will give you a message that this server host key is not cached in the repository. Just click on yes on this message. And now you will see the screen which says login as, right? So now since I was launching an Ubuntu instance, what I have to enter over here is Ubuntu. I'll hit enter and now it will verify the key that I inserted and it will be able to connect to the Putty, to the server that I created on AWS using the key that I put, right? And now I'm logged in on my server. Now I can do anything over here. I can install any software that I want. So this is how you can connect to an EC2 instance which has launched a Linux AMI or Linux OS. Okay, for connecting to Windows, guys, you do not get a PEM file. You do not get a PEM file. What you basically get is an RDP file along with the password. Okay, so you will be given the password, you will be given the username, you will be given a RDP file. So you select the RDP file and then it will ask you for the password. Just enter the password that was given to you by the AWS Management Console. You click on connect and then you will be able to launch a Windows instance. So there are only two types of OS that you can launch on AWS. One is Linux, second is Windows. So I told you how to connect to Linux instances. Let me also walk you through how to connect to a Windows machine. Alright guys, so now in order to launch a Windows instance, again we'll just click on launch instance. Let's select a Windows OS which is free tier eligible. Let's select this. Right, t2.micro is the instance that we want to launch. Let's click on next. Let's leave everything at default. Let's click on next. Here you can see the default size is 30 GB because in Windows it takes a lot of space. So it's 30 GB over here. Let's click on next. Configure the security group. Here you can see that instead of SSH you have RDP, right? Because for Linux instance, because it's a command line, what you do is you collect through SSH. But because Windows is a GUI based OS, you have to connect through RDP. All right. So we'll click on review and launch. And now we'll select the same key pair which was there. And let's click on launch instances. So our instance is now launched, guys. We can just go here and we can see it's in the pending state. All right. So let's name this instance as Windows. All right. And now in order to connect to it, this is the IP address that you get. Now just click on actions. So select the machine that you have to connect with. Once it's launched, you'd be able to click on actions and you'd be able to click on connect. So in the connect, so when you click on connect, you will get all the options of how to basically connect to this particular server. So let's wait for this instance to be in the running state and then let's review. Okay, so the instance is now in the running state, guys. Now let's click on actions. Let's click on connect, and this is basically the way to connect to it. You can download the RDP file by clicking over here. So as you can see, I got the RDP file. The username is administrator, and if I click on get password, it says password not available yet. Please wait at least 4 minutes after launching an instance. Okay, so the password will be available once the instance is 4 minutes since launch, but this is the way you get the password. Okay, now if I click on the RDP file, it will directly give me this kind of a window where it will say, are you sure you want to connect to it? Let's click on connect. And now it is asking for the password. So all you have to do now is wait for the password to be available over here, right? And once the instance is ready, you'll get the password here. Once you have the password, just put the password over here, click on OK, and you should be able to connect to your Windows instance. So let's give it the time. Let's wait for this instance to get in the running or in the password state, and then we'll just enter the password here and click on OK, and let's see how it goes. Alright guys, so let's try now. So I just click on actions. I click on get Windows password. I get this page. Now what I have to do is I have to choose the key pair path. So in this PEM file will work. So I'll just enter the test intellipaat.pem. Remember, the PEM file will work and not the PPK. Let's click on open. And now let's click on decrypt password. So guys, this is the password for connecting to my instance. Let's copy it, go to our instance, let's paste it over here, and now let's click on OK. Now it says the identity of the remote computer cannot be verified. It's okay, just click on yes. And now you should be able to connect to your server. So here you go guys, here is a server launched on AWS for you. It's a fresh server. You can do anything that you want on this, right? You can install any kind of tool on this. You can make it a database server, make it a web server. You can make this server anything. Okay. So guys, this is how you can connect to a Windows instance. I've showed you how you can connect to a Linux instance as well, right? This also, you can install any software on this server and it can become anything for you, right? Now, let's go ahead and come back to our slides. Alright guys, so I've showed you how you can connect to an EC2 instance. We got to know how to connect to a Linux instance. We got to know how to connect to a Windows instance, right? And let's talk about the other services as well. So let me come back to my dashboard. So like I told you guys, EC2 is an infrastructure as a service where you get access to the operating system, right? Now there is a service called Elastic Beanstalk and there's a service called Lambda. Let's look at Elastic Beanstalk. How is the dashboard look for Elastic Beanstalk, right? So as you can see, it says welcome to AWS Elastic Beanstalk, and it says just select a platform, upload an application and run it. That's it. You don't have to connect through SSH to that instance in order to install the software and get your application ready, right? So as you can see, when I said get started, it gives me create a web app, right? So you can only create a web application here. It will not act as your backend server, right? It can only host application. So let's give it an application name. Let's say it's test. Okay. And then let's choose a platform. What do I want that software or that web app to run? So I can put my web app in .NET. I can put my web app in Go. I can put my web app in PHP. It's all my choice. So let's click on PHP, right? And the application code, let's have the sample application first. And now let's click on create application. So these were all the settings that you had to do, guys, nothing much, right? And now it will start to create your Elastic Beanstalk. It will not give you an access to the operating system. Remember this, guys, you will not get an access to the operating system. All you will get is a dashboard on which you can upload your website and it will be hosted for you. When I created the EC2 server, I could not do anything on it. I had to install the software, then I had to put my application on it, and only then I'll be able able to access it. But in this case, everything is done automatically. I can just upload my code and that's it. All right. So let's wait for this to be ready and then we'll go forward. Alright guys, so as you can see, my Elastic Beanstalk is now ready. And now if I go to this particular URL, which Elastic Beanstalk has given me, you'll be able to see the web app, right? This is a sample application which has been deployed. I can click on upload and deploy and just I have to choose a file, click on deploy, and that website will get deployed automatically over here. I will just go to this link, refresh it, and my website will be visible over there. So I guess now you know when I said that you just get an access to a dashboard, you're actually not getting an access to the whole operating system, right? You do not have a control on that. All right, let us look at Lambda as well. So let's see what happens if I click on Lambda. Alright, so when I click on Lambda, guys, this is the dashboard that you get. And as you can see, it just says run. So if I run it, it says hello world, right? You just have to enter the code here. It will give you the output. That's all what Lambda is. It will not host your application. It can just give you textual outputs in the form of JSON or in the form of textual content. It can just give you that. Okay. Now, if I change something over here, let's make it hello world 123. If I run it, it says hello run world 123. So if you want to create a function, just click on create a function over here. Author from scratch, use a blueprint, browse serverless app repository. You can just see if there's any code that you want to take from what has been done before. You can do it from here, that browse serverless app repository, use a blueprint. Here you have a lot of blueprints which most of the companies use, right? So you don't have to write the whole code from scratch. You can just click the blueprint that you want. For example, it's a microservice HTTP endpoint. That is, you just have to hit on the API and it'll give you the result. If that is the kind of Lambda function you want, you can also do that, right? Then you have kinesis, fire assist, log to JSON. There are a lot of things over here. Don't get confused with all the jargons used over here, right? This you will be able to get once you have a hang of all the services in AWS, which we will teach you in the upcoming sessions, right? For now, you just understand what Lambda does, right? Lambda, you give the code, it will run the code. That is it. It will not host an application. Elastic Beanstalk, it will host the application for you. And EC2, you can do anything. You can also configure your EC2 server to basically become AWS Lambda, but you'll have to manually install all the softwares and then you'll be able to do that job. So I guess hope guys that you are now clear with the basic services of the compute domain of AWS, that is EC2, Elastic Beanstalk, Lambda. Auto-scaling and load balancing, we will do it as we move along in the sessions because that requires you to know a little bit more, right? So let's move on and come back to our PPTs and let's start with our next domain now. Alright guys, so our next domain is the storage domain in AWS, and let's see what all services do we have in the storage domain. So guys, these are the important services that we have in the storage domain of AWS. Our first service is Amazon S3, then we have Amazon Glacier, Amazon EFS, and AWS Storage Gateway. So let's look at these services one by one and understand what they do. So guys, S3 is an object storage service, which basically means that all the files which are uploaded on the S3, they are basically regarded as objects. Objects for us as layman users, they don't differ much. I mean, you won't see the difference in terms of when you're using the file or downloading the file that, you know, it was a file before and now it's an object. Object basically is at the back end. That is how you store a file is in the form of an object, right? So it's basically on the infrastructure side that it makes a difference, that each file in an S3 bucket acts as an object, right? Now, why do we use S3? Why do we need a storage service, right? Is because, like we have discussed previously, that we need distributed systems on an application. The more distributed it is, the more fault tolerant it becomes. When I say fault tolerant, basically it can tolerate faults in its nodes. Each node in the application, whether it be the storage node, the compute node, it could be the backend compute node, the database node, each of these nodes, if they fail, right, it can tolerate that failure in your application can still be working. Okay, so Amazon S3 is a file storage system by AWS which says that it will give you the availability of 99.99% times. That means only there's a 0.01% probability that your service is going to fail. Otherwise 99.99, it's actually not 99.99, it's 99.9999, 4 times 9, right? That is the kind of availability that AWS guarantees that your object will have. And obviously you can increase this SLA, this is basically called a SLA, service level agreement, that what kind of service will AWS provide to you. You can further increase this SLA by providing redundancies, by using certain techniques wherein you can take a backup of your bucket at every 24 hours, so that if there is a data corruption, you can always get that data back, from the vaults and then store it back again in the bucket. But that is only when you have failure in the S3 service. And for that, I told you the probability is 0.0001%. Okay, that is the kind of service that AWS provides. So you can be rest assured that if you want to host files on AWS, if you host it on S3, your files will be available pretty much all the time, right? That is what you have S3 for. Now, what are the common use cases where you will be using AWS S3? You can imagine it like this, that if there is a website wherein the logo is there, if there are certain images on that website that have to be loaded at the time of a web page reload, all those images will be taken from S3 and will be presented over there, right? So rather than storing all these files on the server on which the website exists, you can store all these files, all these images on S3, and then you can just get it from there, right? S3 also provides you the facility of hosting static web files, right? So you can host a website also by using an S3 bucket, and all you have to do is enable static hosting on that bucket and you will be able to host static websites in that case. Alright, our next service, guys, is AWS Glacier. So AWS Glacier is an extended version of the S3 service, which is the Glacier does not give you a direct access to itself. It basically takes a backup of the S3 service. So let's say you created a folder in S3. So folders in S3 are basically called buckets, right? The root folder in S3 is called bucket. So if you have a bucket and you have a lot of files inside that bucket, and if you want to take a backup of all those files, you can take it using the Glacier service in AWS, right? And Glacier service, the reason we have two services over here, the reason for that is that S3, you can get the objects instantaneously. The moment you put the link of the object, you can download it, right? You can access it. But when we talk about Glacier, it takes time for the object to be retrieved. It takes times in hours, sometimes 2 or 3 hours to retrieve a file in Amazon, right? So that is the kind of service that Glacier is, and it's a backup service and it's also cheap. So the main difference between S3 and Glacier is that if you are taking a backup in Glacier, it'll be very, very cheap. I think it'll be 1/10 of the cost of the same size of files which exist on Amazon S3. The reason for that is Glacier is strictly a backup service, and because it is low priced, because of that there are some compromises in its performance, wherein the time to retrieve the object, it takes time, right? It takes 2-3 hours to retrieve an object in Amazon Glacier. When you compare it with Amazon S3, it's instantaneously, and that is why even the price is higher on the S3 service. More about pricing we'll talk as we move along in the session, right? But right now it is very important to understand the functionalities of these services, right? So why do we use AWS S3? For hosting our files, and those files can then be retrieved on whatever application we want. It's basically anywhere on the internet. If you put that link, you will be able to download that file. So that is what AWS S3 is for you. If you want to take a backup of AWS S3, then you can use AWS S3 Glacier, which will help you to take backup of any buckets or files which are there in your S3 inside it, right? After Glacier, guys, the other service that we're going to discuss is EFS. So what is EFS? EFS service is again a storage service, but it's different from S3. How is it different from S3? That EFS service can be mounted on your operating system as a volume, right? Isn't that interesting? So you can mount Amazon EFS as a volume on any computer on the AWS network, right? So let's say you launch a server of Windows on AWS and you feel that, you need a network drive. If you guys have worked with network drives, then EFS is exactly a network drive. It mimics the usage of a network drive, right? And it's also scalable. That means the size increases as and when you need it, right? So that is scalable. It can be attached to multiple computers. That is, it can serve you as a shared drive. That is, there could be tens or hundreds of computers which have the same volume inside them, and that same volume would be EFS for you. So how does that help? That helps when you have a scalable architecture where there are 7 or 8 systems, and whatever changes one system is doing, that has to be seen by the other system as well. So in those kind of cases, you use EFS, wherein they will have a common drive on which the data will change dynamically. No matter which server is changing it, all the changes will be available on the other servers as well. And that is what EFS is for you guys, right? So EFS can be mounted on Windows machine. It can also be mounted on Linux machines. And the way you use it is, I just told you, it acts as a shared drive. And where do you use it? You use it where you want shared data between multiple servers which are working in an architecture. All right. So that is what EFS is for you guys. Then our next service is AWS Storage Gateway. So it basically helps you to connect an on-premises system to the AWS cloud infrastructure. So if there is any storage application which is there on your on-premise systems and you want it to be connected to the AWS infrastructure, you will be using the AWS Storage Gateway service. All right. So guys, this was all about the storage domain in AWS. Let us quickly jump on to our AWS Management Console. So I'll show you a few of the services in AWS that ways. So let me jump on to my Management Console. All right, guys. So here I am on my Management Console. The first service that we discussed was under storage, which was S3. So let's click on the S3 link, and that will give you UI which will look something like this. So I have some buckets already configured. You can create a new bucket. So like I said, bucket is nothing but the root folder where you put all your files, right? So let's say the bucket name is test-Intellipaat, right? This is the bucket name. Then the region that I want to put this is, let's say I want to put it in Oregon region, and that's it. Let's click on next and keep all versions of an object in the same bucket. Leave everything at default. Just click on next. Leave everything at default, and now let's just click on create bucket. Alright, so my bucket is now created. I can go inside this bucket and I can upload files over here. Let's try to upload a file. Let's click on upload. Let's click on add files. Let's go to pictures and then let's try to upload something. Let's go to documents. Let's say I want to upload a file, and let's say I upload this particular file. Okay, so this is the file that I want to upload. I'll just click on next. It will now upload it. Click on next again. Here are the so this is basically the types of classes that you can access, right? Do you want to access, put it in S3, you want to archive the data, put it in Glacier, all those you can do. Let's click on next and click on upload. So right now we have not changed any setting in S3, right? We are just uploading an object, and as you can see, my file is now uploaded over here. Right now, if I select this file, I can actually see the properties of this file via this link. Right, here's an object URL that you get. If I click on this object URL, it will say access denied. Why access denied? Because first I have to make that object as public. So for that, what I have to do is I'll be going into properties, right? And over here, I will go to permissions, and then I will go into public access, right? So right now it says you can't grant public access because block public access settings are turned on. Let's go ahead and remove those things. So I'll just go to Amazon S3, click on the bucket, and then let us click on permissions. And in this permission, I want to edit block all public access. I've done that. Let's save this thing. And to confirm these settings, just type confirm, hit and confirm, and my settings are now done. Now let's go back to overview. This is my object, right? And if I refresh this, it says still there's access denied. Now what I'll do is I'll go to permissions, and now I'll give public access. So I want to give read object to everyone. Let's click save. Now if I go to the website, hit refresh, I can see the image over here. Now this link, anybody who has access to this link will be able to see this image. So you can also embed this link in your website and you will be able to load that page on your website just like that, right? So this is what the link does. This is what the link is all about. So if you upload an object, guys, and you want to make it public, just go to the permissions of that particular object, make it as yes, and you're set. All right. So this is how you can read from S3. All right, guys. So now let's start off with EFS. So I'll just click on the EFS service on my AWS management console. I will reach this page where I will have an option to create a file system. Let's click on that. And now it will ask me for the VPC that I want my EFS to be created in. Now remember, guys, the VPC that you select here should be the same as the instances on which you want to mount the EFS volume. So right now it's VPC 4B58233. Let's click on next step, right? Leave everything at default, guys. Don't touch anything else. Let's create the file system now. Alright, guys, so my file system is now being created. Now remember, guys, the security groups that are attached to this particular EFS drive has to be the same as well for your EC2 instances. Okay, so how to check which security group is this EFS drive mounted on? You can check that by You can check it over here in this table. So right now it is in creating state. So once it is available, you will have the security groups listed over here. Okay. Now, since my EFS is going to take some time to set up, let me show you the instances that I've launched. So I have two instances. One is Ubuntu and the other is Ubuntu 2. I'm going to mount the same EFS volume, which I've created over here to basically connect to these two instances. Right now, how to do that? First, I will click on, let's connect to our Ubuntu instance. Let's connect to this Ubuntu instance first. So this is the IP address, and I guess I've already connected to this IP address, 172.31.51.195. This is the private IP address for the Ubuntu instance, and this is the same, right? So even this is the same. So let's close the extra terminal from here, and now let's connect to our second Ubuntu instance as well. So this is the IP address, guys. Let's copy it. Let's launch a new putty console. Let's paste the IP address. Let's select the PPK and let's click on open. For clarity, let us change the colors of the terminal. Let's make it orange so that we can differentiate between the first instance and the second. So as you can see, the IP address for this is 172.31.51.17, and the IP address is same over here as well. So that means we have two Ubuntu servers that are now open on my putty terminal. And what we will be doing is we'll be connecting this EFS mount point to my Ubuntu instances. So this is a security group, guys, 7F087236. Now we'll have to ensure that both my instances have that security group associated with it, right? So if we have to check the security group for my Ubuntu instance, here it is, guys, the security group which you'll have to connect. So what you will be doing is you'll be going to networking, you'll go to actions, go to networking and click on change security groups. So as you can see, it is only launch visit 1 has been connected to it. My security group that I have to connect is 7F087. So this is the security group that I have to connect to my instance. So let's connect both of them, right? And now let's click on assign security groups. So my Ubuntu instance is now connected to the security group of my EFS. Let's do this to our second instance as well. Let's select the default security group that is there. Great. So now both my instances are connected to the security group of my EFS, right? Now what I'll be doing is I will be following a set of instructions that you will find on this console as well, right? So the first thing that you have to do is on an Ubuntu instance, you will have to install this package. Let's do that. So this is my first instance. Let me copy the command and it is already installed. Great. Let's do the same on our second instance as well. So let's first update the machine, sudo apt get update. All right. Once it's updated, the next step would be to run that command. Now let's run that command and my NFS common package will install over here. Right now what I can do is I can create a directory on my first instance. Let the directory be EFS test. Okay, great. And let's create a directory here as well. Let's name it as EFS test 2. Okay, now what I'll be doing is I'll be mounting my EFS volume. So for mounting it, just copy this command, go back to your server, paste the command and put the directory name. So in case of my first instance, the directory name is EFS test. Let's hit enter. Great. So EFS test directory is now connected to my EFS volume. We'll verify whether that is working or not, right? Let's similarly copy the command over here as well. And this would be EFS test 2. This is the directory name. Great. So even this instance is now connected to EFS. Let's go into EFS test 2. Great. Now, as you can see, if I do an ls over here, there's no file, right? Similarly, if I do a ls over here, there's no file. Let's create a 1.txt file. Let's put sudo. Great. If I do an ls, you can see there's a 1.txt file over here. If I do a ls over here, you can see there's a 1.txt file here as well. That means this is a shared volume, correct? If I create, let's say, one more file over here, if I do an ls over here, I can see the 2.txt is also available. Similarly, I can create a file from here as well. And if I do an ls over here, I can see that the 3.txt file is also present. So guys, this is how EFS works. It acts as a shared drive between multiple instances in AWS. All right. So let's come back to our slides, guys, now. So guys, we have successfully discussed what S3 is, we discussed what Glacier is, we discussed what EFS is, and we have discussed what storage gateway is. Our next set of services belong to the database domain. So let's go ahead and understand these services. So the first service, so guys, the database domain comprises of these many database services in AWS. The first AWS service that I have is Amazon RDS. Then we have Amazon DynamoDB, Amazon Redshift, and in the end, Elastic Cache. So let's understand these services one by one, starting off with Amazon RDS. So guys, Amazon RDS is nothing but a relational database service. Guys, it's not a database, it's a database service. What do you mean by that? Is that you will, under the RDS service of AWS, you can launch these many databases. You can launch the Microsoft SQL Server, you can launch the MySQL service, you can launch the Oracle SQL, PostgreSQL, MariaDB, Amazon Aurora. You can launch all these databases. But what is RDS for? RDS basically manages these databases. Now, how does it manage? It makes sure that it takes automated snapshots of all these databases, which will be corresponding to a particular time. It can also ensure that if there are any read replicas required or if there are any replication required in your database, that also can be taken care of RDS or by RDS. Third thing is it also takes care of any security patch which has to be applied on your database if you enable automatic updates, right? So this is how RDS works, guys. Now again, let me emphasize on the point that RDS is not a database. It's a relational database service in which you can launch all these relational databases. All right. So guys, I hope RDS is clear with you. Next service is Amazon DynamoDB. Now, what is Amazon DynamoDB? It's basically a NoSQL database by Amazon, right? And what is a NoSQL database? Whenever you have to store unstructured data, that is data which does not follow a particular format, you use unstructured database like DynamoDB. Now, alternatives to this, you might have seen or you might have heard about MongoDB or you might have heard about other NoSQL databases. This Amazon DynamoDB is a NoSQL database by Amazon, right? So there is no database that it supports. It itself is a database unlike RDS, and in this you can store unstructured data. Okay. Third service is, guys, Amazon Redshift. So Amazon Redshift is a data warehouse service, which basically what it does is under the data warehouse you will have multiple databases. So those databases can be queried by your warehouse, and it looks as if all the databases, they combine together to give one database where all the data exists, but it is actually not like that. Amazon Redshift comprises of multiple database engines which it can connect to and give the output as required. Next service is Amazon Elastic Cache. So Amazon Elastic Cache basically is a service which serves as a cache. So what is a cache? A cache is a layer between the client and the web server or the server from which the information is being requested. What happens is, let's imagine imagine you want to get the data for an employee whose salary is greater than 10,000, and you basically want to get all the current cities that the employees are staying in, right? Now let's say you do this query time and again. Now what happens, your server is again and again doing a query on the database using a particular query that this is the data that I want. Now what happens is, when again and again you're doing the same query, it does not make sense to run the same query again on the database, let it do the computing work and then get the results. So for these kind of data, what Elastic Cache does is, whenever it sees that there's a frequently accessed data, it stores that data on the cache, which means whenever a similar request will come, rather than querying the database, the same data will be going back to the customer from the cache layer itself. So it decreases the overhead on the database, and it also at the same time increases the performance of your application. All right. So that is what Elastic Cache is all about, guys. Alright guys, so our next domain is the security domain. So in security domain, these are the following services that we have in AWS. So we have the first service, which is AWS IAM, and the next service is AWS KMS. Let's check out both these services and understand what they do. So guys, IAM is basically used to authenticate users to your AWS account. Now, the account that you just created on AWS, it basically is the root account for that AWS account. Now, what happens is, big companies or companies like Netflix, Airbnb, they own only one AWS account. And what they do in that AWS account is they create multiple users with restricted permissions. Okay. So each user can have their own user ID and password, but basically they will be logging into the same AWS account. And that is possible using AWS IAM, right? So you can create multiple users for a single AWS account with granular permissions, such as what actions can they do on the AWS Management Console. You can also restrict them to particular services that they can access. For example, the user can just access S3, or he can just access EC2, or he can just read EC2 and cannot stop and start an instance, or he can just start and stop an instance but cannot create a new instance, right? Or you can put also a restriction that nobody can terminate an instance whoever users you are adding, right? The account or the user that you signed up with, that is basically the root account. Now what is the root account? Root account always has all the privileges, right? It has all the privileges, can do anything. But if you have to put any restrictive access to a particular person, you'll have to create a user account in IAM. So that is one type of account that you can create in IAM. The second type of account that you can create in IAM is an application account. Now what is an application account? Let's say I have a website which can upload data to S3. Now how do I authenticate my website to upload data on S3? For that, we have the AWS IAM service, using which I can create application identification keys as well. So what you get in that case is you get access key and you get a secret access key. So that access key and secret access key has to be embedded in your program, and only then your program is authenticated to upload data onto the S3 service of your AWS account. Otherwise it cannot, right? So this is one of the reasons, or these are actually the reasons that you use IAM for, right? It can help you to put restrictive access on user accounts as well as application accounts. All right. Moving forward, guys, the next service is KMS. KMS means Key Management Service. So Key Management Service is basically used to create the key pairs that we saw while we were creating EC2 instances, right? So those key pairs are actually created by the KMS service, right? So similarly, if you want more key pairs to be created, you just have to head on to the KMS service and you can create your key pairs over there and authenticate yourself accordingly to whatever service you want. All right. So guys, this was the security domain. Now let's move on to our next domain, AWS Services Management. Alright, so this is our next domain, guys. So let's see what all services are included in this domain. So guys, these are the domains that are included in this, these are the services that are included in this domain. So first service is AWS CloudFormation. Then we have AWS OpsWorks. Then we have AWS CloudTrail. And in the end, we have CloudWatch. Now, what is AWS CloudFormation, guys? AWS CloudFormation is basically used to templatize an AWS infrastructure. Okay. So let's say I have launched two EC2 instances with a load balancer in an auto scaling group, which is connected to an an RDS instance, which in turn is also, connected to my EFS. So all these things I will have to launch, right? If I know what the architecture is, I will have to launch everything one by one, and then probably my architecture would be ready. But what I can do with CloudFormation is everything I can specify in a JSON file. So in a JSON file, I can specify all the resources that I want to launch, all the things that I want to configure in the network, everything I can specify in the JSON file, and just run it through CloudFormation. So what CloudFormation will do, it will create that whole architecture according to my JSON file. So I don't have to stress too much on, creating my architecture one by one using either through my management console or through my CLI, right? I can directly do that by just writing a JSON file and passing it through my CloudFormation. So this also helps us when we want to replicate our architecture across multiple regions, right? Let's say I have an architecture in one particular region. I want to replicate it across multiple regions. So in that case also, CloudFormation helps us a lot. So it's an automation tool which can help us to launch AWS resources by specifying it in a JSON file. Our next service is AWS OpsWorks. Now it's a little similar to CloudFormation because this also deals in automation, but basically this is a configuration management tool. So if you guys are aware of DevOps, there's a configuration management tool called Chef, right? So Chef recipes are readily accepted by AWS OpsWorks, and what you can do is in AWS OpsWorks, what happens is there are multiple layers that you have to configure, and all these layers together they form to become a stack. Okay, so what I'll be doing is, let's say in the first layer I specify the EC2 instances that I want to automate on, right? The second layer could specify what all software that I want to be configured in that EC2 instance. So that is how OpsWorks is helpful, guys. So a configuration management tool is nothing but which can configure all the software requirements on a particular set of servers at the same time, right? That means if I have to install, let's say MySQL on, let's say 100 servers, how will I do that? It's a very daunting task. I'll have to go to each server, I'll have to install MySQL. So OpsWorks makes it easy for me, and it makes it easy in a very effective manner. That is, every server will have the same configuration that I specify in OpsWorks. Now don't get confused with CloudFormation and OpsWorks, guys. CloudFormation is used to deploy an architecture. OpsWorks is used to specify consistencies in that architecture with respect to the softwares that we are going to install in that. Okay, so and also it's not just a one-time deployment that you'll be doing through OpsWorks. Let's say tomorrow your database link and the password is changing, right? And you have some 200 servers in your fleet. How will you do that? So that is possible using OpsWorks. All you have to do is just go to that layer where you have specified the link and the password, just change that and update or deploy the OpsWorks architecture. And then in that case, it will update all the servers with that very small change that is specified in one of the layers, right? So for all these very small changes, which are very important and have to be same across all the servers, I use OpsWorks, right? Next service, guys, is AWS CloudTrail. So AWS CloudTrail is basically a monitoring service which logs everything which is happening in your architecture, right? So that logging is not enabled by default to some of the services. You can enable logging by specifying that, AWS CloudTrail should log each and every action which is happening. And it exactly does that. It basically would log each and every action or each and every event that is happening inside a particular AWS resource once you attach AWS CloudTrail to it. And then that log data, basically you can use to do further monitoring by connecting it to probably a BI service which can visualize your log data, etc. Right? So that is what AWS CloudTrail is all about. Then our next service is AWS CloudWatch. Now what is CloudWatch? CloudWatch is basically, again, it's a monitoring service, but it's a little different kind of monitoring service, right? So what you can do with CloudWatch is you can set up alarms. For example, if let's say I want an alarm whenever one of my servers goes in unhealthy state, right? No, so how would I do that? So one thing would be that I continuously hire my employees and they are constantly checking if my servers are in the healthy state or not. Or what I can do is I can configure it'll take very less time to just configure my CloudWatch, to monitor all my resources, and whenever there is a resource which goes in the unhealthy state, it can trigger an alarm. Now, what kind of alarm can it trigger? It can either email you, or it can basically trigger a next set of events. It can trigger to create an EC2 instance, or it can trigger an AWS Lambda function. It can trigger something else as well. So this is what CloudWatch is all about. It watches all your resources, and on basis of that, it can do a simple process that you define in CloudWatch. Okay, moving forward, guys, our next domain is customer engagement domain. So in this domain, we have the following services. The first service is Amazon Connect, and then we have simple email service. So let's look at what these two services do so that they are so helpful in the AWS community. The first service being Amazon Connect, guys. So Amazon Connect is nothing but it's a full-blown customer contact center for your company. For example, you would have seen that whenever you purchase a product, there's always a customer helpline that you can call on, right? And then you get the IVR options in there where you choose, and then you get connected to human agent to talk your way out, right? Or you to put your grievances and you talk to your customer service agent, right? Now, if you want to set up something like that for your company, it is very simple to set up that using Amazon Connect. You can build a customer contact center in less than 5 minutes with Amazon Connect, right? All you have to do is go to Amazon Connect service, click on get started, and it will allot you a toll-free or a normal phone number based on what you choose. After that, you just have to fill in the agents that you want to be on the other side, so that whenever people will be calling that one particular toll-free or normal contact number, they should be routed to the agent screen, right? And this happens on the internet, so there is no need of purchasing carrier plans or something like that, right? So this is what Amazon Connect is all about, guys. Our next service is simple email service. Now, this is also plays a vital role in customer engagement. You would have seen that you get marketing emails from a lot of companies. For example, if there are food companies that you order for, or if you have went into a store, you gave your phone number over there in the contact list, they'll also message you. Pizza delivery stores or grocery stores, they all email or SMS you one way or the other, right? This service right here is when you want to have email interactivity with your customers, right? You can send bulk emails. You can also set up your simple email service to respond to particular reply emails, right? So that is what SES is all about. And this also can be configured to route emails. For example, if there is an email address that you set up for your company, for example, support@intellipaat.com is our email address, right? So if you email to that particular email address, it will get routed to our support agents who will help you out in solving your queries, right? So that all can be set in Amazon SES. Guys, so this is it for the customer engagement services. Our next domain talks about app integration, right? So in this domain, we'll basically have services which help you to integrate 2 or 3 services in AWS. Let's look at what services they have to offer. So there are 2 services basically, guys. One service is called simple notification service, and the other one is simple queuing service. Let's see what these services are. So the first service, which is Amazon simple notification service, basically helps you to send notifications to other AWS services in occurrence of an event, right? So it waits for a trigger to happen, and based on the trigger, it sends a notification to a corresponding AWS service which has to work next. For example, you can set up a website which can send you an email, and all you have to do is, let's say, whenever a customer purchases something from your website, you want to trigger an email to the customer with all the details. Now, if you have to do this on a distributed environment, what will you do is the moment there is a trigger that there is a cash payment received from a particular customer, your Lambda event will be triggered, right? Now, that can be triggered in numerous ways. One way is either your service can directly trigger the Lambda event, but that is only possible for some of the AWS services. The other way around is that you can send a notification to to SNS, right? So SNS will detect the type of notification received and it will have a mapped out row as to which service it has to notify next. So in this case, it will receive the notification. It will see, okay, so this is the type of notification received. It will invoke the Lambda function, which will basically send out the email to your customer. All right. So this is how an SNS service basically works. As you can see in the diagram here as well, that you have a publisher. A publisher is a person who sends out the notification, right? The next thing that you do is the way of filtering out different kind of notifications in SNS is that you define topics. Okay, so based on the topics, the messages are filtered, and what you do is in the topics you will define which service to basically trigger, and based on that those services will be triggered, and the services to be triggered are basically called subscribers. Okay, so guys, this is how an SNS service actually works. Moving forward, now let's look at the simple queuing service. Now, what is a simple queue service? It's basically a queue it's basically a place where you can store all your jobs whenever you have a stateless kind of an architecture. What is stateless kind of an architecture? Let's say you have a system which doesn't have its own memory. The prime example for this would be AWS Lambda. So what AWS Lambda does is it does not know what is happening in your application. Okay, what it knows is just the job that it has to do. For example, let's say the job of the Lambda server is just to send an email, right? It will not know whether it has already sent an email to a particular customer or not. It will not know whether it has already sent an email to a customer, right? What it will do is it will just pick up jobs from the queue that you have, and based on that it will perform the job. And that is exactly why you have a simple queuing service, so that it can feed to Lambda what the next job is without Lambda having to remember what it has to do, right? So guys, this is what the SQS service is. Now guys, this was all about the different AWS services that we have and that you need to know in order to get started with AWS. So I think we have almost covered all the use cases that you can encounter in an organization, and basically your job would be to that based on the problem you would have to suggest an AWS service, and that AWS service implementation also details you will have to know, right? So based on the knowledge that I've just given you what each and every service does, you can now decide what an architecture should basically have in order to get a job done. All right, moving forward guys, now let's talk about a very important topic, which is AWS pricing. Now we know about all the services that we're going to use, right? But what will we do or how will we use these services totally depends on the pricing of these services, correct? So let's move forward and understand how the pricing model works in AWS, and if I'm using a set of services, how will I be charged? How much will I be charged? So guys, the AWS pricing options are among these three, right? The first option is pay as you go model, which means whatever amount of time you will be using an instance for, or whatever amount of time you will be using a server for, that amount of time will be billed to you and will be given back to you. So whenever you will be launching any server, you will get a per hour basis charge on that particular service, right? So you can see that service, you can see what the charges are, and accordingly you will be charged whenever you terminate that instance, or whenever there is a monthly billing cycle of yours which is ending, right? So the first model is pay as you go model, which is widely used. Second model is save when you reserve. Now what do you mean by that? Let's say you're launching a website today, right? And that website is for your company, and you foresee that I will be at least running this website for the next 3 years. Based on it's just a startup, I might not see that much growth, but I will sustain it for 3 years. In 3 years my website is gonna there, right? Let's say this is the scenario. So what you can do with AWS is you can opt for dedicated instances or reserved instances. So you can say that I'm going to use this instance for 3 years from now on, right? And I'm not going to back out. I am going to use this instance for 3 years. Then what AWS will do for you in that case is it will give you a counter offer. It will give you a discounted price, right? Reason being that it is no longer an on-demand service. It's a service that you have asked from AWS, which you will use for 3 years, which means that you will have two options in front of you to get this kind of a deal. One thing is you can do a full upfront payment of 3 years, years, right? You can pay all the whatever discounted price they deliver to you. You can just give the amount for 3 years and you can use your instance, right? Then you're locked in. Or what you can do is you can also do a partial upfront payment if that eases out the financial stress on you, right? For example, you do not have that kind of money to pay for 3 years. So what you can do is you can divide your payments into EMIs and then you can pay it to AWS. That's a partial upfront payment. So with this, you can get discounts up to 70% of the pricing which is there in pay-as-you-go model, right? So the guys, that's very cheap. So if you have an application where you know the server that you're going to use is going to be there for like 2 or 3 years, then it's better to go for reserved instances where you can opt for taking a server and you'll get huge discounts on using them. All right. The third kind of pricing is pay less by using more. What this basically means is the more you will be using your instance, for example, your instance, the type of pricing that you get, for instance, is on a per hour basis, right? The more you will use your instance, the less the hourly rates will become, right? So that's also an awesome feature by AWS, which says pay less by using more. All right. So guys, these were the pricing options in AWS. There's one more pricing option that you get in AWS, which is called spot pricing. What is spot pricing or spot instances? Spot instances are basically idle instances which AWS is running, and what it does is it offers it to you in a cheaper price, right? So for example, it's 2 p.m. in the afternoon and I know that the load is less at this particular time. So what AWS will do is it will offer you some instances at a lowered price rate because those are just sitting idle over there, and if you want to use them, you can use them. So what happens in that case is you take that instance and you bid it, right? If you want to take that instance, you'll have to bid amount on that particular instance. The higher the bid amount is, obviously that bid amount will be lower than the actual rates, but the higher the bid amount is, that instance goes to that particular person, right? Now there is a catch in this, basically, that if somebody bids higher than what you have bidded, in that case your instance will be stopped immediately and it will be given to someone else who has done the bidding higher. All right. So that's a catch over here, but it could be particularly helpful when you are dealing with workloads which are not that important, but anyways you have to do them, right? In those kind of scenarios, you can take up spot instances and you can just bid a particular amount which you feel you are comfortable in, and in case in future the price goes up, your instance will be stopped, but at least you're getting your work done in a cheaper rate, right? So that's the ideology behind spot instances. So I guess now it's clear with all of you what AWS pricing options you have. Now let me move ahead and let me tell you a very exciting point about AWS pricing, right? The free tier. So the free tier is basically one-time offer that you get whenever you sign up. So whenever you sign up on AWS, if you are using a T2.micro instance, which is 1 GB of RAM and 1 vCPU of computer, in that case, it will be totally free of cost to you, right? So what you do get in a month is 750 hours of usage. So you can launch 4 instances, 5 instances. All of them together collectively can be run for 750 hours. The moment you cross 750 hours, you'll be charged the normal price. But up till 750 hours of server usage, you will be not charged a penny, right? And this is what the free tier is all about. Now, it is particularly helpful for people who are trying out AWS, or people like us who are trying to learn AWS for our future careers, right? So I'll request you all guys, so whenever you're practicing on AWS, always be under the free tier, because that is literally not going to cost you anything. All right. So the 750 hours that you get are particular to EC2 and RDS. Apart from that, you get some other free tier limits as well. For example, in S3, you have, if you store data up to 5 GB, you will not be charged anything. Okay. Then in DynamoDB, if you have to store something, which is if the instance which you're running is under the free tier, and if you want to store something on DynamoDB till 25 GB, it is absolutely free. Okay, so guys, this is the kind of pricing that you get. These are the kind of perks that you get when you're using AWS for the first time. For more details on AWS free tier, you can just visit the aws.amazon.com official website, and they'll give you all the details. There are a lot of other services as well that they offer free tier in or free limits in. For example, the Amazon Connect service that we discussed, which was basically a one-stop customer support center setup. In that, you get in a month you will get the first 90 minutes of your calling for free. And the way you get charged for that particular service is not on the number of hours that you'd be using that service, but on the number of minutes a customer is speaking to an agent, right? That is how you get charged. That's, I think, pretty cool about Amazon Connect. Alright, moving forward guys, I think we have covered enough of theory. Now let's go ahead and do a hands-on where basically I'll show you guys how to set up your AWS services and how to migrate an application from your local computer onto AWS. So let's start off with our hands-on. So guys, what I've basically done is I have created a website using which we can upload data on S3. Okay, so this is how the architecture looks like. So basically my website can upload data on AWS S3, and that record is also saved in a MySQL database. Now, as of now, this MySQL database is on the local host, and also the website is on the local host. And right now my website cannot connect to S3 because it is not being able to authenticate itself. All right, so this is what we are going to, the first step that we're going to do is we're going to authenticate our website to AWS S3 to upload data. Once we have done that, we will migrate this website onto AWS infrastructure. All right, so without any ado guys, let me first show you how my website basically looks like. So let me jump on to my browser. Right, so guys, my website basically exists on localhost/new. Right, so this is how my website looks like. The first thing that I would have to do is I will have to check if it is able to connect to a database. So basically whatever I will be uploading, I can view that over here as a list, but right now it cannot connect to the database. So what I do is I'll open up my MySQL on my local host. Here it is, right? And now what I'll do is I'll create a database called images. So because that is what I have configured in my code, right? And now let me create a table with the name names, and let there be one field called name with the value as varchar, and let us give pretty big value so that any length of characters can fit in this particular table. All right, so it says no database selected. Oops, I'm sorry for that. So use images, and now let's create the table. So when I do a refresh over here, it should be able to connect, but now it will show you an empty list because there's nothing inside my database, right? If you want to show anything over here, it will basically be visible once the entry is made inside the database. Second thing is, right now if I try to upload anything, let me go to pictures and let's say this is the image that I upload. If I click on open and if I click on submit, my file basically will not be uploaded. Reason being, it will say the authorized header is malformed, which basically means authentication is not yet given to my account. Now, how can I give authentication to my website so that it can upload on S3? For that, I'll have to head on to my AWS Management Console, and as we have learned, there is a service called IAM. So I will go inside that IAM service, and over here what I'll do is I will create a user. Right, and let's say the username is web demo, and what I will have to give this user is the programmatic access, so that by code this user will be able to access all the services on AWS. Now the kind of services that I want my website to access is only S3, right? So let us put in S3 over here, and as you can see there's a permission over here which is Amazon S3 full access. Let's give this access to this particular user, and let's review it, and let's finally create the user. Once we have created the user guys, I will have the access key ID and I will have the secret key, access key. Now this is very important for my application to be authenticated. So what I'll do is I will just copy this access key ID. I will go to my terminal. I will create a new page, and this is my access ID guys, and this is what my secret access key looks like. Okay, so this is my access key, this is my secret access key, and this will be used to basically connect my website onto AWS S3. Okay, now let me show you how my index or how my code looks like guys. So guys, this is my code which I'll basically use to upload files onto S3. As you can see, the key and the secret key are not filled as of now. So let us fill the key first. So the key is this. Let us enter it over here, and the secret key is this. Right, so once I enter the key and access key, secret access key, my website will now be able to authenticate itself onto S3, and now it should be able to upload objects into a bucket, right? Which bucket are we talking about? Let me quickly show you. So there's a bucket that I've just created on S3, and that bucket name is basically test Intellipaat. So as you can see, there are no objects in this bucket as of now, right? And now what I'm going to do is let me refresh this website. And as you can see, now it says new record created successfully. That is, the image that I chose earlier should now be uploaded over here. So now if I do a refresh, I can see there's one image that has been uploaded. Let's upload one more image for the sake of understanding it. Let's upload this particular image and let's click on submit. So what happens is the moment it takes up a file, it changes the name of the file into a random name, and then it uploads it over here. So if I refresh, you can see there's one more image which just has been uploaded. Now what I can do is I can just go back to my website and I can just click on checklist. So this will give me a list of files which are uploaded onto my S3. If I click on this list, I can basically download the file from S3, and if I click on it, you can see the file. This is what I uploaded, right? Similarly, if I click on it over here, this is the file that I uploaded, right? Similarly, let me upload one more file so that it's clear for everyone. Let's say I upload, let us not take an image. Let us try to put something else. So let's say there's this app, there's test.jar that I can upload. So let's just click on open and let's click on submit. So this is the file. I click on submit, and now if I do a refresh over here, I should have that file. Okay, so that file might be a little larger in size, that's why it's not uploading. So what I can do is let me take this particular image, right, and let me submit this. As you can see, a new record has been successfully created. If I click on checklist, there is a new image which has been added. If I click on this image, I can clearly see that this is the image that I uploaded. Similarly, if let us try some other file as well. Let's choose a file. Let's try to upload this Excel file. Let's click on submit. And when I do that, a new record has been created. Great. If I check the list, this is the Excel file that has just been uploaded. If I click here, the Excel file is downloaded. If I click open this basically file should now open, right? Great, guys. So I think our website is working fine, but the problem is this website exists on my local host, right? And right now it is basically feeding data onto my local MySQL instance. So if I basically would just do a select star from names. This is the name of the table. You can see that this is all the values that are there in the table, and these are the values that you can see over here. So the first thing that I should do is basically let us deploy a database on AWS through which my website will basically be connected. For that, I will be heading on to RDS. Since this database that I'm using is MySQL, let us try to deploy a MySQL database on AWS. So for that, I will be clicking on create database, and the type of database that I want is MySQL. Let's select that, and now let's click on next. Next, I want to create a dev environment or test environment because this is just a POC. So I've selected this and I'll click on next. Next, I can select the MySQL version. So let it leave it at default right now. And I want to enable only options which fall under the free tier usage. Okay, so let's select this option. And everything is filled automatically. Let's identify our DB using a name. Let's say it's web-demo, right? The master username, let's say the master username is Hemant. Let's specify the master password as well. And now let's finally click on next. Right now it will ask me which VPC do I want to put my instance into. So I have the default VPC where my instance is being launched in. That's great. Second thing is public accessibility. Do I want internet to be able to access RDS? So yes, I want public accessibility to be enabled. If I select no, in that case, there will not be any public IP which will be assigned to my RDS instance. Only the VPC in which my RDS instance resides in, only instances launched in that particular instance or in that particular VPC would be able to access that RDS. So when I say VPC, it's basically a virtual private cloud, or it's basically a virtual network, right? So if I do not give public accessibility to my RDS, then it will only be able to connect to machines which reside in that particular network on which it is being deployed, right? Not on the internet. Okay. So, but because our website right now is in my local host, from local host, I should be able to upload data onto the database of AWS. So for that, I will need public accessibility, right? Do I want to create a new security group? No, I don't want to. Let us select the default security group. Okay. What should be the database name? So the database name would be the same that I've given for my local MySQL instance, which is images. Rest you can just leave at default. Backup, I don't want any backup, so let's select 0. And disable monitoring, we don't want that. We don't want any upgrades made to my database, right? And I think that's it. Now let's finally click on create database. Now guys, the database instance, it takes around 3 or 4 minutes to create. Meanwhile, while this database is being created, let me tell you the next step that we have to do. Now, since this website exists on localhost, I want this website to be existing on basically AWS. I want this website to be uploaded on AWS. And for that, let us use Elastic Beanstalk, which is the platform as a service on AWS, right? So let's open the AWS Management Console, and now let's head on to Elastic Beanstalk. In Elastic Beanstalk, you can basically upload your website, and I'll show you how you can upload your website, and you don't have to configure anything on the instance. Every software, everything will be configured by Elastic Beanstalk itself. So as you can see, when you reach this page, you just have to click on Get Started, and now it'll ask you the application name. Let's say the application name is web-demo. Right? What platform is my website based on? So it's based on PHP. Do I want a sample application to be deployed previously? Yes, I do. So I'll just click on create application now. So guys, this will basically create a web app for me in Elastic Beanstalk. We have done this earlier as well. We're doing it once more so that we can upload our own website onto this particular Elastic Beanstalk application. Okay, so it'll again take guys 3 to 4 minutes for Elastic Beanstalk to get deployed. Meanwhile, let's check if our RDS is ready. I'll just head on to RDS. I can see there's an instance which is running. So it is still in the creation phase. So once the creation phase is over, you would be able to get an endpoint over here. So an endpoint is basically a URL through which you will be able to connect to your database. All right. So let us wait for this database to be ready. And once it is, I will try to connect to this database from my localhost and see how that goes. Right, so it's in the creating phase. Similarly, my Elastic Beanstalk is also being created. Let me show you my code, guys. Let me explain you my code a little bit. Right, so this is my main file. So in this file, basically, I am using the PHP backend language on which I have basically imported the AWS SDK, right? This SDK, you can basically just Google AWS SDK for PHP and you would be able to download it. Now I have included this particular folder in my root directory of my website, which is over here. So this is the folder which has all the libraries, right? And my index.php will basically has included this particular library, and then the service that I want to connect to is S3. So we are using the libraries of S3 over here, right? My bucket resides in Oregon region. The code for that is US West 2. This is my key. This is my secret access key. Don't worry guys, I will be deleting the user account, so don't try using these keys. They will no longer work once I have the username deleted. Apart from that, it's pretty simple. It's a very straightforward code, guys. Right now, the database that I'm connecting to is on localhost. That's why the server name is localhost. When I would want to connect to my RDS instance, all I have to do is change this server name to the endpoint of RDS, and then it should work like a charm. Right, that's it. This is my index.php. My list.php, where I get a list, is basically I'm just connecting to that same database which exists on localhost, and I'm trying to read everything from the table. This is the field that I'm reading. On the front of that name, I'm attaching this URL. So this is the URL for my bucket. and this remains the same for each and every object which gets uploaded, right? So I'm uploading, so I'm attaching this along with the name, and this I am basically storing in an ahref tag, which basically gives me a link on my website, right? So if I can show you over here, as you can see, this is a list, right? And this is the link. So this link is basically a ahref link in which I have embedded this URL with my file name. All right. So once I've done that, it works great. It works like it is supposed to. Now, I guess we should go ahead and check if my RDS is ready. Yes, guys. So my RDS is now in the available state. So how do you connect to RDS? There will be a database which has been created on my RDS, but still the table is still not created, right? So first I'll have to create a table on this RDS instance, which would basically be exactly the table like what I have on my local host. So how do I connect to my RDS? So just copy this endpoint, guys. And now you'll have to go on to CMD, right? So once you are on the CMD, guys, the next step is to go to the bin directory of your MySQL installation. So my MySQL installation is basically in WAM64. So I'm going to go in there, right? So I'm inside the bin directory now. Next thing would be that I will have to call in MySQL. -h would be the host name. The host name in my case is the Amazon's host name, which is this. The username for this RDS instance, it's Hemant. And the password is this. Let me specify it over here. Let's hit enter. And now, if everything has went well, I should be able to connect to my RDS instance. Let's wait. So while this is happening, guys, if it gets stuck like this, it could be that you're not able to connect to your instance, and the reason for that could be in the security group. So you'll have to check if the inbound rules for the security group are open to accept traffic. So let's click on inbound, and yes, so this is the problem over here. It's allowing all traffic, but it's only allowing to this particular security group. So what I'll do is I'll make it anywhere and I'll save it. Once I do this, let us come back here and try to run the command again. I'll enter the password and hit enter. So as you can see, I have successfully connected to my MySQL instance, which resides on AWS. Now this instance should have a database called images. Let's use that. And now let's create a table which would be the same as what I did on my local host. So the table name would be names, and the field name would be name, and the type of information that can go in is varchar. Let's specify that. Okay, so my table is now successfully created, guys, and now my database is ready to basically take in data. Now what I'll be doing is let us go back to RDS and let's copy this endpoint, and now let's make our website maybe be able to basically interact with my RDS instance. So it's pretty simple. Just change the server name to the endpoint of RDS. The username in my case is Hemant, and the password in my case for my RDS instance is Hemant1994. All right, that's it, guys. That's all we have to do. And let's save this code. Similarly, in my list, I will have to change the values from localhost to these variables. I'll save it. And now when I go back to my website, let us open the local MySQL instance also. So this was my local MySQL instance. As you can see, there are only 4 entries over here, right? Now let's choose a file. Let's try to upload the same XLXX file, the Excel file that is, and let's now click on submit. So it says new record created successfully, but let us check here if this is where my data has been entered. So no, my data has not been entered over here. Let us check on my RDS if my data is being entered correctly over here. Select start from names. So yes, a data has been entered over here with the this particular name. And if I click on checklist, as you can see, even here I get the same value. So you can compare that this is the name that I'm getting over here, and this is the name that I'm getting on my website. If I click here, I'd be able to download that Excel file successfully. Great guys, this is what I wanted. So now my website is basically connected to my database instance on AWS. It was that simple. Now the next step is basically to put this website on AWS for good so that everybody in the world can access it. Now how can I do that? This is my Elastic Beanstalk guys, and this is the dashboard that I get when I use the platform as a service instance, right? Now it says here upload and deploy. So that's what I'm going to do. I'm going to click on upload and deploy. And now it's going to ask me to choose a file. Now the way you can upload your website over here guys is you will have to go to your website codes, right? And then you will have to zip these files like this, right? So once the files have been zipped, this zip has to be uploaded over here. So I'll choose a file. Let me go into that folder where I have the zip. Here's the folder. Let's click on open. Version label, let's try to give this version label as 1.0. Okay, and now let's click on deploy. So now my website is now getting deployed to AWS Elastic Beanstalk. It will hardly take some 2 or 3 minutes for my website to be ready on this particular platform. And once it is, we'll be able to use it via this particular link. This link will basically be my application now that I've shown you on localhost. This will now be available on this particular link. So let me close all the unnecessary windows. And now let's wait for this to be ready. Okay, so it will take around 2 to 3 minutes, like I said. And whatever version that I've specified, that version will now be reflected over here. Okay, so it would be AWS 1.0. So let's say in the future I make change to my code, any kind of change to my code, I would be able to upload it over here in the same manner possible. That is, I will have to click on upload and deploy, and then I will have to increment the version. I will show you that as well. Let this complete, and then we will go ahead and check. So as you can see, my running version is now AWS 1.0. Great. So this is what I wanted. Now it's the moment of truth. Let's try to go to this URL and see if our website is working or not. So great guys, my website is now available on this particular URL. Let's try to check if it is able to upload everything. So let's first check a list. So we have one file which is there in my database, which is uploaded. Now let's choose a file. Let's try to upload the zip file itself, right? I'm not sure if it will be able to upload. Let's check. So the uploading has started. It says new record created successfully. Awesome. Let's go here. Let's refresh this. As you can see, a new entry has been made. Let's try to download this. So as you can see, the zip is being downloaded. And if we go to our S3, if we refresh over here, you can see the zip is present over here as well. And my zip is also downloaded. If you want to verify if all the contents are fine or not, let's do one simple step. Let's create a new folder here, right? And now let's try to paste this extract over here. It will extract all the files. Click on OK. So all the files are now being extracted. Let's do a Control X and let's paste here. Let's delete these files. So basically on my localhost hello, there should be a file. My website should be up and running. So localhost/hello. So as you can see, I can see my website over here. And if I do a checklist, if I do a list.php here, I should be able to see even the list. So that means these files that have now been uploaded to S3 are working correctly. And also I have successfully migrated my website, which is there on my localhost, onto Elastic Beanstalk without even going to the terminal, without installing any software on the server, right? It is now up and ready, and anyone who will visit this particular URL will be able to access my website. Okay, and as simple as that guys, and it's basically hosting my files as well. My files are now all available on this particular link. So anywhere in the world, if anybody would go to this particular link, they will be able to access these files. They just have to click on it and they'll be able to download it. All right. So thank you guys. I think this is it for this session. Let me just come back to my slides.
As I already told you, in this session, we'll be looking at a hands-on. So before moving on with the session, let me briefly show you what is going to be the output of our hands-on. So this is our localhost and this is our Elastic Beanstalk. So first in localhost, what I'm going to do is I'm going to upload this doc1.pdf and I upload it. So the file has been uploaded successfully. So now let me open Amazon Web Services account and I'll open my S3 bucket. So first I'll open the S3 service, and inside that there are already buckets which I've already created for this demo. So first let me go to from the bucket, because in this bucket I'm going to store all the files which have been uploaded. So first, so you can see already there was a doc one, and right now another file has been uploaded, and also because it is the same name, the file will be overwritten with another name of the current time and the file name. So we have uploaded one more file. Let me show how it works in Elastic Beanstalk too. So it is the same operation, the same code in Elastic Beanstalk. So let me upload another file. So I'm uploading this photo here. So I upload it and the file has been uploaded successfully. So in S3 now, if I reload it, and you can see that file has been uploaded. So the final output is going to be, so we go to the bucket image. So you can see I already had two images, and now there is another image which we uploaded already in the bucket, from the bucket. So here you can see to the bucket PDF, and if you go inside you can see the doc one, and this one was uploaded from this local host. So you can see here that it has the same name as this one. So it is exactly the same file which was uploaded here, and it was copied to that bucket. So how did we do that using AWS Lambda? That we'll see in this session. So first let us learn the theory concepts of this session, and then we'll move on to the hands-on part. So come on, let us go.
Okay guys, now let us begin with the session. So typically an application comprises of three components: the front end, the back end, and the database server. Before the cloud technologies emerged, when a company wanted to host their application, what they did was they used to host all the software components, that is the front end, the back end, and the database service, on an individual server. So what happens here is, whenever you want to do an operation, like consider this website is for storing photos like Google Photos. So you upload a photo and then press the button upload in the website. So what happens now is the website does not process. It goes to the backend service. So whenever you click something here, so the process goes to the backend code. Some code is triggered. So what happens is that code runs, and after that, if you wanted to upload the photo, it will store somewhere. It will use the backend's help, and it will store somewhere, and it will show the response in your website. Also, there needs to be information stored in the database, because there is a name for the photo, there is a link where the photo is stored, and also there will be other properties like size and something else. So they will be stored in the database service. So what happens here is all the software components are hosted in an individual server. Whenever you wanted to do an operation, you click some button or do some operation on the website, which will trigger a service in the backend. So that will happen, and if there needs to be any data stored, it will be stored in the database, and the output will be shown on the website. But what is the problem with hosting all the software components on a single server? The main problem is it has limited resources. So let me explain this. So consider your website is getting a lot of traffic and it is using 80% of CPU's resources. And at the same time, the backend service needs 50% of the CPU's resources to run operations in the backend. So what happens here is front-end service uses 80%, but the backend service only gets 20% of CPU's resources to work on. And if a database service wants to use some resources, there are none left for it to use. So right now the system falls under a deadlock, and the whole server will be in a problem. So what happens is they cannot be scaled, and also this is the reason why the websites get crashed. Hosting all the software components on a single server is quite easy, but it comes with all these possible drawbacks and demerits. So what is the solution for this? Let me provide you the solution with an example. Let us see that. So the solution to this is using a distributed application architecture. So what is a distributed application architecture?
It is basically using dedicated servers for each of the software components. The front-end software component is hosted on its own dedicated server, so does the backend and the database. So the front-end server only hosts the website, the backend server only does the backend operations, and the database server only is used when there is a need for the database service. But how does this improve the situation? So let me explain that. Consider the backend service under a lot of traffic or workload. So what happens now? Basically, in an individual server, when all the software components was hosted, so what happened there was backend server will consume most of the CPU resources, and the other services will not have enough CPU resources, which leads to a crash. But what happens here is only the backend server will be having workload on that. The other two servers will be left unharmed. So considering the backend server has used all of its resources and has crashed, the other two servers will not have any harm on them. The front-end server will still be hosting the website, and this website will be still visible to the users. Even though the backend services won't be running at the current time, the users will not be able to use the services provided by the website, but the website will still be visible on the browser. So how does this solve the scaling problem? In this particular architecture, you just have to scale the particular servers which you want to scale. Actually, so here we consider that the backend server is using all of its resources, and you only want to scale that particular server. So you can just do that. You can just scale your backend server instead of scaling all the three components. Obviously, this is going to reduce a lot of cost and time. And for example, if you want to only increase the space for your database service and you want to scale your database service, you can just scale that. So to understand this better, let me give you a real life example. Let us consider Google Photos as the example. So here you can see the website. So this is the front-end server, and the images which are being retrieved are using the backend service to do that. And also the links for these images, the data, that is the name of this image, the size of the images, are all stored in the database service. And whenever to retrieve this particular image, the database service provides the link, and the backend service will use that link to show the image to us. So let us consider this, and let me explain how all these services work together. So whenever you search anything on the search bar, so I have two images named hello and hello yes. So I'm searching hello over here. You can see there is photo ID over here 1 and 2. So the names are hello and hello yes, and the site links are this. So this is the site link for the first image, this is the site link for the second image, and the backend service retrieves these information and it will produce it over here. So this is how the front end, the backend and the database services club together. So now we have learned what is a distributed application architecture and how the front end, the backend and the database works together. So now let us move on and see what is AWS Lambda. So AWS Lambda is a serverless compute service, which means you don't need to worry about servers while building and running applications. You will just have to code as per your needs, save it in Lambda and relax. It will take care of everything else like provisioning servers. We will learn more in depth as we move along. So now, what distinguishes Lambda from EC2 and Elastic Beanstalk? They all are compute services, right? But there is a difference. Let me give an idea about that. First, let us compare Lambda and EC2. Later we will move on comparing it with Elastic Beanstalk. Let me start with the first difference. Lambda is a platform as a service, while EC2 is an infrastructure as a service. In Lambda, it provides you a platform to run and execute your backend code, but in EC2, it provides you virtual computing resources. The second difference is that Lambda restricts to a few languages like Python, Java, C#, and a few more. No restrictions in EC2. You can install any software you want in the platform given to you. And then you can choose the environment like Node.js or .NET and push your code into it in Lambda, but not in EC2. In EC2, you have to decide the operating system and then install all the required softwares, and then you have to upload your code or code internally and then execute. And then moving on, Lambda does not provide you the luxury of choosing OS and runtimes, but in EC2 you can configure every single aspect like different instance types and security preferences. So this is what makes them different. I hope you understood the difference between these two services. Now let us discuss what distinguishes Lambda and Elastic Beanstalk. Let me start off with the first point. Lambda can only run your backend code, while Beanstalk can run your entire application without you worry about the infrastructure which it runs on. Secondly, Lambda provides resources based on your workload, but in Beanstalk you have the flexibility to choose the instance type and other configurations. In Lambda you don't need to worry about any configurations or instance types. So the last difference is Lambda is stateless system and Elastic Beanstalk is a stateful system. So what is the difference between them? A stateless system is when the output is based only on the current inputs, not using any other inputs which were stored before. But in a stateful system, it may provide different values for the same inputs by comparing the older inputs. Being stateless provides Lambda the ability to create millions of process threads and execute them all with different inputs simultaneously. Okay guys, now we understood how does EC2 and Elastic Beanstalk services differ from AWS Lambda. Moving on, we'll first take a look at benefits Lambda provides and the limitations of Lambda. First, let us look at the benefits provided by Lambda. Later, we'll move on to the limitations of Lambda. The first benefit is that it provides a serverless architecture. So you don't need to worry about provisioning and managing servers. You'll just have to concentrate on building and running the application. So to be very simple, you will be given a console. You choose the language, write your code and hit run. It chooses an EC2 instance according to the required processing power. The next point is code freely. There are multiple programming runtimes and editors, so you can just choose it freely and code it in like how you do it in an offline editor like in Visual Studio or an Eclipse. The next point is no virtual machines needs to be created. You don't need to create and configure any EC2 virtual machines. As I already told, they are provided by Lambda according to the processing power needed for your function. The next point is pay as you go. Pay as you go is a feature provided for all services in AWS, and what is here is in Lambda you will be only charged for the number of seconds your Lambda function runs on for the particular seconds how many services have run, and that's it. You won't be charged anything more. The fifth point is monitor your performance. You have a default monitoring option in Lambda which is connected with CloudWatch and this particular Lambda function which generates multiple logs and metrics for you to visually and textually understand what is going on in your Lambda function. So whatever advantages a service provides, there will always be some limits to it. So now let us take a look at the limitations of AWS Lambda. The first limitation of AWS Lambda is the maximum disk space provided is 512 MB for the runtime environment. This means the /tmp directory storage can only store 512 MB at the same time. Why do we need /tmp directory storage in Lambda is that because we need a temporary storage for storing the current Lambda function's inputs and outputs, because the same Lambda function, there is no guarantee that it will execute 2 or more times. The next limitation is that the amount of memory available for Lambda during execution is 128 to 3008 MB. So this is the amount of RAM you can choose between either 128 or 3008, and between that it is a 64 MB increment like 128 plus 64, and it keeps on adding. The third limitation is that the function timeout is set only to 900 seconds. So the maximum amount a Lambda function can execute is 15 minutes and the minimum is 3 seconds. So if you want your Lambda function to execute more than 15 minutes, that is not possible. It can only execute to 15 minutes and the default is 3 seconds. So maybe your Lambda function's execution completes in 1 second, but it has to run at least 3 seconds to stop. The fourth limitation is that the only available languages in Lambda editor can be used for writing the code. The languages are like Python, C#, Java, Node.js, Go and Ruby. Okay, alright guys, we've seen the pros and cons of AWS Lambda, so now let me give you a brief idea on how Lambda actually works. Okay guys, now let us move on. So first, what you do is you write your code on the Lambda editor or upload it in a supported programming language in a zip file. So it is not that you have to create only one Lambda function. You can create any number of Lambda functions your application needs, and after that the Lambda executes the function or the code in your behalf. You don't need to run it. So but to run the code you need to trigger the Lambda function, right? So how do you trigger it? It doesn't run automatically. you need an external AWS service which can trigger and invoke the Lambda function. So for example, it can be an S3 bucket or a database. So what happens is whenever a write operation occurs in the database, your function should be triggered. So you set that as a trigger, and whenever a new record has been uploaded or inserted in the database, the Lambda function will be automatically triggered and retrieve the information which you need from that. So after that, we know that the Lambda code is running, but where does it run? It needs a server or a computer to run, right? So what it does is it provisions servers and also monitors and manages it. So how does it provision servers? So Lambda functions have various types of code. So if your code requires a lot of processing power, it will choose an instant type which has more processing power and RAM. Or else if your Lambda code only executes for 2 seconds, it will choose the lowest possible instance. This will save you money and time. Okay guys, now we understood how Lambda actually works. So what are the various concepts in Lambda? Let us look into it. So now we are going to see various concepts in Lambda, and the 4 concepts you are going to see is functions, runtimes, layers, and log streams. So what is a function? A function is a script or a program that runs in AWS Lambda. So the Lambda, whenever it is invoked, this function runs. So you can see here, this is the function name, and here you write the code. So the function processes the event and returns a response. So let us see some function settings. So here you can see the code. The code is the logic you use in the Lambda function, which you write over here. And then runtime. Lambda runtime executes your function. So whatever runtime you choose, that particular code it will be written here. So that will be executed by the Lambda's runtime. And then the handler. The handler is where you mention the function's name with the file's name. So whenever the Lambda function is invoked, this particular function is executed. And then tags. Tags are key value pairs which you can mention for any AWS service just to track their cost or track their metrics. And then description. Description is describing a function which you can give while creating a function in Lambda. And then timeout. You have to set the timeout between after 3 seconds to 900 seconds, because that is the capacity, or that is a timeout period for a function, which I've already discussed in this session. So let us move on with runtimes. So what is a runtime? A runtime allows functions to run in different languages in the same base execution environment. That means in the same environment, you can run a Python file, a Java file, and a Node.js file. And this runtime sits in between the Lambda service and your function code. So it is in between. So whatever code you send, there are multiple runtimes, and it will choose the correct runtime for your file. If it is Python, it chooses Python runtime. If it is Java, it chooses the Java runtime, and it runs and gives you the executed response. So also see, you can take a look at multiple various runtimes. So these are the latest supported runtimes, and these were already announced. So first it's .NET Core 2.0 C#. So and then Go programming language, and then Java, Node.js, Python 3.7, and Ruby 2.5. And the other supported languages are Node.js, but an old version 8.10, and Python an old version of 2.7 and 3.6. Okay, now let us see what are layers. Okay, so Lambda layers are a distribution mechanism for libraries, custom runtimes, and other dependencies. So instead of downloading using the code which you write in your Lambda function, you can create layers and store those particular libraries or custom runtimes which you want to run your program in, and you can store it in multiple layers, and you can create only 5 layers for a particular Lambda function, and you can upload it so that there is no confusions while the code is choosing a particular library or a custom runtime. For example, if your code needs to run a particular library which it needs for uploading information to an Excel sheet for a CSV file. So what you do is you upload that particular library to a layer, keep it in order so that your code chooses the appropriate layer and gets out the libraries. So after that, also your layers lets you manage the in development function code independently from unchanged. You don't need to change your code or resources that uses. You can just upload the information in a zip file as layers and take information out of that, and you can create multiple layers. The maximum number of layers is 5 per function, and you can use layers which is provided by AWS customers or already available layers, or you can create your own layer. And then comes the log streams. This is the part where you monitor the Lambda function. So normally, Lambda automatically monitors your function invocations and reports metrics to CloudWatch. If you don't want to just watch metrics, you can write the code in your Lambda function so that you can get logging statements for each and every step your function goes through, and you can look at the execution flow and how your Lambda function is performing and whether it's working properly or not. So moving on, now let us see how AWS Lambda works with S3. So here we're going to see how exactly an operation in the S3 bucket can trigger the AWS Lambda function. So consider a user is trying to access a website which you can use to upload photos. So if you upload a photo here, it will be stored in the AWS S3 bucket which it is connected to. Also, whenever a put operation occurs, that is when file is uploaded to the S3 bucket, the Lambda function will be triggered. So for example, you can use it as a put operation or a get operation. So consider it is a put operation for now. So whenever the user is uploading a photo here, so it gets uploaded to the S3 bucket, and when it's uploaded, the Lambda function is triggered. So the Lambda function's code can be anything. You can make any microservice out of it. So if you want to store the file's name and the location, you can store it in the database using the Lambda's code, or you can watch the CloudWatch metrics, and you can also look at the logs which you have coded in the context of your program. So after that, you can also copy this particular file into another S3 bucket using your Lambda code. Also, if it was a get function, like if it was a get operation, if the user is trying to download a photo, again the photo will be downloaded, which is from the S3 bucket which is stored there. So you can use that also as a trigger in the Lambda function, and you can make any microservice out of it. So this is how S3 is used as a trigger with Lambda functions. So now we understood how this works theoretically. So now it is time to move on for practicals. So now let us do an hands-on on creating an S3 bucket and then using a Lambda function to copy it to various multiple S3 buckets. So why does it go to various multiple S3 buckets is because we have mentioned a different type of file extension. So if it is an image, it goes to a different bucket. If it's a PDF, it goes to a different bucket. So whatever the file extension is, it goes to a different bucket. So let me explain that part now. Okay guys, now we are going to do a hands-on using multiple AWS services. So let me show you what we are going to do exactly before moving on with the hands-on part. So what we are going to do is, I already told you how Amazon S3 works with AWS Lambda. So what we are going to do is, we are going to create a simple website which can upload a file to the S3 bucket, and whenever a file is uploaded to the S3 bucket, the Lambda function is invoked. So what happens is, we are going to upload three types of files. One is a .jpg file, a .pdf file, and a .txt file. So whenever an image file is uploaded, it goes to the image bucket. Whenever a PDF file is uploaded, it goes to the PDF bucket, and whenever a text file is uploaded, it goes to the text bucket. And we are going to do this all with a simple Lambda code. And what we are going to do is, we are going to use the S3 buckets uploading, that is put as or post as a trigger, and whenever an object is uploaded to the S3 bucket, the Lambda function will be triggered. Okay guys, now let us see this on the AWS Management Console and how to do this practically. Okay guys, at the beginning of the video I told you that I'm running this file both on the local host and the Elastic Beanstalk. So to understand it better, first let me explain the local host part. So let me show you the code first. So this is the code. There are two files, one is index.php and the other is filelogic.php. So let me briefly explain this. This is a simple form which has an input and a button. So input is you click on a file, and button, whenever you press the button, it uses filelogic.php to execute the uploading to the S3 part. So here I'm mentioning the bucket which I'm going to upload to, and here you can see my credentials. So this is my region and version I've given latest, and these are my secret keys and the key which I have, so that it can access my AWS account and that particular bucket in my AWS account and upload it over there. So here you can see if that particular object with the same name exists, what it does is it adds $time in front of it. So if that same file exists, what it does is, normally if it does not exist, $key will be just $key, but if a file exists in the same name, if doc1.pdf and I'm again uploading doc1.pdf, so it takes the current time and adds it in front of the file name. So this is why we saw in the beginning of the video there was one doc1 and it had another doc1 file with a time duration in front of that. So now we have seen this code. Now let me show you the Python code which is used for the lambda function. So in the lambda function, using that we are going to send this particular objects from one bucket to various buckets using their extensions. So let me explain that also briefly and let us move on to how to do this using the AWS infrastructure. So this is the Python code, and first I'm importing some things which I need actually. So I'm importing JSON, I'm importing os.path. This is for getting the extension, and I'm importing Boto3. This is mainly important because Boto3 is the AWS SDK for Python. This allows Python developers to build and run applications on AWS using this. So you can write Python applications using Python programming language when you include this particular Boto3. So, and I'll explain this briefly. So this is the source bucket. I'm getting the name here. This is the file name. I'm getting it here. And copy source, I'm giving bucket, source bucket and key. So this is why I imported JSON. So I'm recording the copy source as the bucket which I'm going to upload it from, and this is the object which is going to be uploaded, and this is our CloudWatch info. So if I print it over here, it will be available in the CloudWatch streams. Like, you can go to that log streams and check out these things when the function has started. So when the function started, this will be there, and after that this information will be given. So, and then here comes the logic. The logic is pretty simple. You first check whether the object exists. If it doesn't, you check whether extension. First you get the extension or the last 4 characters, that is either .jpg, .pdf or .txt. So even if it is a file with a different extension, if it is a .png, the file will only be available in that particular bucket. It won't be copied to any other bucket. If it is .jpg, it will go to the bucket image. If it is PDF, to the bucket PDF. If it is txt, it will go to the bucket txt. So s3.copy object bucket, this is the destination bucket, this is the file name, and this is the copy source, that is the file which you're going to upload from the bucket. That is, from the bucket is the name of that particular bucket. So also if it does not exist, so this will be printed in the CloudWatch log stream. Okay guys, now we've seen the code. Let us move on to the AWS implementation part. Okay guys, let us start from the beginning. So first you have to go to the IAM management console because you have to create a role. So first thing you have to do is you create a role. I've already created a role test. So I'm going into that, and you have to attach a policy. And I've created a policy already, which is s3_move. So you have to create a policy and use this particular JSON code inside it. So what I'll explain what this means. So I'm giving effect allow, and also over here. So here I'm giving the actions logs, create log group, log stream, and events. So I'm allowing all these events to happen in the CloudWatch whenever I'm using this particular policy. So in S3 I'm allowing all operations like post, get, put, whatever operation it is, I'm allowing it to happen. So I'm giving effect as allow. Also they should have a unique resource name, so I'm providing that. So without this particular policy and role, you can't do this. So you can't basically do what I'm going to do right now. So we cannot copy S3 buckets objects into multiple S3 buckets. So you have to create this role and policy and use it in the Lambda function. So the first thing we are going to do now is we are going to create 4 different S3 buckets. One is from the bucket, which is the main source bucket, and we are going to create 3 more buckets which are for image, PDF and text. So let us do that. Before moving on with the S3 part, let me tell you how to do this without copying and pasting this JSON code over here. First you have to create a role which lets Lambda call other AWS services. So here, after clicking on create role, you have to choose Lambda so that it can be calling other AWS services. And next you have to give it permissions. You can see here there are a lot of permissions, that is, there are policies available. So before we created a policy s3_move, and we pasted that JSON to allow access to CloudWatch logs and S3. So what I'm going to do now is I'm going to give full access for S3 from searching here. So I searched S3 full, so I got full access for S3, and I'm searching CloudWatch full. So here you can see I got CloudWatch full access too. So I gave both. So next I'm going to tags. I don't need any tag. So I'm reviewing. I have to provide a role name. So I'm going to give this as practice because I'm not going to attach this. I'm just explaining you how this is going, how to create a role and how to attach policies to it. So you can see here there are two policies attached: Amazon S3 full access and CloudWatch full access. So what I'm going to do now is I'm going to create this role. So I've provided create this role, and now the role has been created. And as I showed you before, here you can see this, and also I can go into the policy and show you the JSON pod. This allows all the actions for S3, and the other policy allows all CloudWatch actions. See, you can see in the JSON. So you can see here it allows everything. So it allows all CloudWatch actions. So that is what I wanted to show you. Now let us move on with the S3 part. So I'm opening the S3 management console. So I already have a bucket. This is for a beanstalk I created earlier. So now let's create 4 more buckets as I told you already. So first bucket is from the bucket. So this is what, so you don't need to configure anything. You don't need to give any tags. So you just click next, and it already sets permissions. So block all public access, and also if you want you can review it once and then create bucket. So this is how you create a bucket. It's actually pretty simple. So then I'm creating to the bucket image, and I've created that. Okay, next thing is I'm creating to the bucket PDF, and I'm giving next, and create bucket. And finally I'm creating to bucket text. So I'm giving next, and I've created buckets. So right now we have created 4 buckets, the 4 buckets which we need, which is in the code for us. So what I'm going to do now is I'm going to move on to create a function in the Lambda. So first what we'll do now is we'll go to the Lambda management console and create a new function. So you can see here I already have a function. So let me create a new one. So author from scratch, use a blueprint and browse serverless AppRest or repository. So using a blueprint is that there are already many things. So here S3 get object Python, config rule change triggered. There are many things. So what we are going to do is we are going to author it from scratch because we are using our own code. So I'm giving the function name as AWS Lambda, AWS Lambda demo, and I'm writing my code in Python. So I'm giving Python 3.7 as my runtime. And another thing, so what I told you, we have created a role and attached a policy to it. So we have to use an existing role here. So the existing role which I told you was test. So I'm using that particular role here. I'm creating the function. So the function has been created successfully. So what we have to do now is see, I'll first explain the dashboard. So here is the configuration and here is the monitoring. So you can see CloudWatch metrics and CloudWatch logs insights. So right now it is loading. So let us see. So it will be empty right now. After the function starts executing, then we can see some data over here. Also we can see the logs in CloudWatch. Let me show that later. So first we'll configure it. So first I'm adding a trigger. Our trigger is going to be S3. So also what I'm going to do is the bucket is actually from the bucket. So whenever an object is uploaded to from the bucket, it has to be triggered. So our bucket is from the bucket, and here I'm put post or copy. So however it may be, if an object is uploaded to from the bucket, it triggers and the function starts executing. So it is all object create events. And here I don't need to give anything. If you just want to copy one particular suffix, like if you want to copy only JPG files, then you can mention it over here. So right now I'm implementing that in the code, so you don't need to give that. Also give enable trigger here and add it. So this trigger will be added. So you can see here trigger has been successfully added. Okay, so the next thing is Now we have to use the code here. So you can already see there is a code written, a simple code. So let us consider this as our runtime right now. So the runtime is Python 3.7. This is the editor to edit the code. This is the handler which I showed you. So lambda function underscore lambda function dot lambda handler. So even my definition, even my function's name is lambda handler. So I don't need to actually change anything over here. So let me copy that code and paste it over here, and let us save this particular lambda function. So I'm going here, I'm copying this code, I'm pasting it over here. So the code has been copied. So you can see the imported function, imported libraries, and here is the print function, and here is the CloudWatch info, and here is the logic to copy from S3 to another S3 bucket. So now let us save this. So once we save it, it is saved. So now whenever a object is uploaded to the S3 bucket from the bucket, then this process will start happening. First, let me show whether it happens or not. So you can see here from the bucket is empty, and to the bucket image is empty, and even these two will be empty because we just created them. So right now I'll manually upload a file to from the bucket. So I'm adding files, I'm adding this image, I'm providing next, and upload. I'm uploading this file to from the bucket S3. So you can see here that the file has been uploaded. Now let us cross check with to the bucket image. So it has to be uploaded to the bucket image because our lambda will be triggered right now, and that function will be running, and this process would have happened. So I refreshed it, and you can see panda.jpg file has been uploaded here. So right now it manually works. So what I have done is I've created a simple web page which can upload files to S3, and then the process happens automatically. So what we are going to do now is we are going to create the same web page which was running in the local host. Now we are going to make it run in the Elastic Beanstalk using a URL. So anyone can upload a file right now, and it gets segregated according to the extension, and it gets copied. So I told you after execution of the function, you can see the CloudWatch metrics. So let me go to monitoring. So here you can see CloudWatch metrics, and here you can see some data. So this is invocations 1. So the function has run one time, and the duration is given here. And also the success rate was 100%. There was no errors. So you can see that here. Also let me show you the logs. So a log has been created. I'm opening that. So you can clear. So function start CloudWatch. So let me open the code first. Okay, so here function start CloudWatch, and you can see the details being delivered there. So log stream name, log group name, request ID. So log stream name, log group name, and request ID has been. So after the request ended, it is ending the report, and the report has been sent. And you can see here it took 566.10 milliseconds, and duration was 600 milliseconds. So it is rounded. So memory size, the maximum memory size was 128 MB. So there was no more memory needed for this function. So now let us move on with Elastic Beanstalk, and we'll create and deploy a Elastic Beanstalk application over there. So let us get started. So let me click on get started. So first thing I have to do is I have to create an application. So my application is going to be AWS Lambda demo, and I have to choose the platform. So my code was in PHP. If your code was in any language, like if it was in Java or Go or Python, you can choose that. So right now I'm choosing PHP. What I'm going to do is right now I'm going to create the application. Later I'll upload the code to make it more clear. So the application is creating right now. So it would take some time. So let us wait and start the processor. Okay guys, now you can see it has been created successfully. So let me show you what actually is there before we do this. So there is a default PHP page over there. So this is the default PHP page, and what we're going to do is now we are going to upload and deploy our application here. Before that, let me explain what actually there is a little change in the code, because the Okay guys, before uploading our application and deploying it, let me show you and explain you the simple change which I made in the code. So this is the code. So here you can see index.php. So there is no change in this, but in filelogic.php you have to change the path because you're going to upload it to an Amazon Linux environment and the path changes there. So it is /var/app/current/your file. So index.php and filelogics.php will be in this directory, and whatever file you upload to Elastic Beanstalk will be in this directory. So what I'm going to do is, you have to click on all the files and choose over here, and you have to archive it into a zip file. So if you ask why should we zip it rather than make the file a rar file or a tar file, because Elastic Beanstalk environment only accepts .zip files. So you can just do it in a normal way. Instead of using WinZip, you can just click on them and you can just send them to a compressed file which will automatically create a zip file. So I've already done that. So now let us upload this file to the Elastic Beanstalk. So let us upload now. So I click on this button, so I have to choose a file. So what I have to do is I have to go back. We go to AWS demo. So this is the file which I have to upload. So AWS uploads file logic and index files are within this particular zip file. You should not create a file on top of this and give that. You have to create a zip file just clicking on these files. So I'm opening it and I'm naming it as AWS Lambda demo. So it is AWS Lambda demo. So I'm going to deploy this. So deploying it takes time. So let us wait until then and we'll check out how our application works. Okay guys, now our file has been uploaded. You can see the running version is AWS Lambda demo. This was the name which I gave for this particular application. So now let me open the URL and show you the website which is running. So here you can see our website is running fine. So what I'm going to do now is I'm going to upload few files to this and check whether it gets uploaded in our S3 bucket and it is moved to the respective S3 buckets for image, PDF and text. But before uploading, let us check whether the S3 buckets are empty or not, so that to make sure that there were no files before and only the uploaded files are getting uploaded right now. So I'm going to, from the bucket it's empty, and I'm checking all the other buckets just to make sure. Okay, now all the buckets are empty. Now let us upload few files. So I'm going to upload 3 different types of files and check whether each of the file goes to its respective bucket. So first I'm going to upload a PDF. It is successful. And then I'm going to upload an image and it is successful too. And then I'm going to upload a text file. So first let us check whether all these files have been uploaded here. So now we can confirm that the doc1 PDF, dogo.jpg and text1.txt have been uploaded to the S3 bucket. So now let us check whether each of the respective files with different extensions get uploaded to their dedicated S3 bucket. So first let me go to the bucket image. Let me refresh it and you can see the .jpg file over here. So next to the PDF bucket and you can see the PDF file over here. And then finally to the text bucket and I'm refreshing it and you can see the text1.txt file over here. So right now our Lambda function is working and it corresponds with whenever we are uploading a file through the Elastic Beanstalk. So Elastic Beanstalk is successfully running our application and it gave us an instance to run it on. So whenever you upload a file using that, our files are getting uploaded from the bucket and Lambda function is triggered, and using this particular logic, if it is to the bucket image, it goes to the bucket image and then PDF and then text. So this is what happening in our hands-on. So before finishing this hands-on, first let me explain the complete process which we did to make this happen. So first we created a policy and first we created a role and we attached a policy to allow all the functions which we wanted to do in the S3 bucket. So and then we created 4 different S3 buckets, 1 for source, 3 for destination. And then we created a Lambda function and we uploaded a code which basically copies from one particular S3 bucket to a S3 bucket which we give the destination name. And we also created a trigger for S3, which is whenever an object is created. So from S3, from the bucket, whenever an object is created, this particular trigger happens and this function code runs. So this function code runs. So whenever this function code runs, what happens is a file from the particular source S3 bucket is copied to the destination S3 bucket. And then what we did, we launched our application, we uploaded our local application into Elastic Beanstalk and we deployed it. And we right now have an URL to run our application. So then now we are going to see CloudWatch. So let me refresh it once more. So we've uploaded multiple files after that, and you can see there are multiple logs over here. So this was the first time, and then you can see whenever the next time the function is coming as function start, and that is the next function. So the function will be keep on running. So you can see log stream name, log group name, request ID. This is one particular function execution, and this is one particular function execution. This is one. So the function has been executed this many times, and the function was started at the first time. So this is how we have to use CloudWatch. Also, you can see the CloudWatch metrics over here in the monitoring tab. So here in the monitoring tab in CloudWatch metrics, now you can see there are totally 5 invocations. So the CloudWatch has been invocated 5 times. That means the function has been run 5 times. And here you can see the success rate. The success rate has been 100% and there are no errors because all the files which we were uploading got uploaded and the function never got any errors and it ran successfully. So right now I hope you guys know how to use Lambda to write a code and use that and use other services like S3 as a trigger to run your particular application. So right now we've learned multiple services. We learned IAM so that we have to create a policy first, and then we know how to create S3 bucket. We know how to write code in a Lambda editor, and then we know how to use CloudWatch, log streams and also metrics, and also we learned how to upload your local application into Elastic Beanstalk so that you will get your own URL. You can access it from anywhere in the world. So use cases of Lambda. There are various use cases of Lambda, but right now we'll discuss 3 of them. So the first one is the serverless websites, the second one is the automated backups, and the third one is filtering and transform data. So let us see serverless website. So I already told you what is a serverless architecture. A serverless architecture is where you just have to code and it automatically takes care of provisioning and managing servers and its infrastructure completely. So what you can do here is you can host your static website on S3. Your static website is basically HTML, CSS, JavaScript or TypeScript files. It cannot run server-side scripts. You can only run client-side scripts. So in server-side scripts like PHP and ASP.NET cannot be hosted on S3 as a static website. And using S3 for static hosting is very cheap. And you can write Lambda functions and connect them with the S3 to correlate it. You can make your static website available using AWS Lambda by writing some code so that the users can keep track of any resources which is being used on the website. So next is automated backups. So the word says you everything. The sentence, the automated backups, you can automatically create backups. You can create Lambda events and schedule them at a particular time on a particular day and create backups automatically in your AWS accounts. So to create backups, you can check whether there are resources idle and take those content and just back it up and delete it from that particular place. And also you can generate reports using Lambda in no time using code or just connecting it with CloudWatch. So you can generate every report and you can see how much of data has been backed up, how much of data has been deleted, and you can manage it very easily and schedule it on time. So the third use case is filter and transform data. So you can connect Lambda with other Amazon services like S3, Kinesis, Redshift, and database services like RDS, DynamoDB, or Amazon Aurora. So you can filter the data before sending the data to any Amazon storage service or database service. You can filter them using the code, and you can easily transform the code and load the data from between Lambda and to all these services. Now let us discuss Lambda pricing. First, let me explain what is free tier. Free tier is provided by AWS for a 12-month period, and in that period you can use free services which are provided by AWS. You can use free tier eligible services. You can use services like EC2, S3 and even Lambda for free, but they have their own limitations. For example, in Lambda, you can use 1 million requests per month or 400,000 GB seconds of compute time per month for free, and anything exceeding that will cost you. Also, you might be guessing what is GB seconds and 1 million requests. 1 million requests is when the Lambda function is triggered 1 million times, and GB seconds is gigabits, that is 1000 megabits per second, that is the transfer rate. So 400,000 GB seconds of compute time per month is allowed. 400,000 GB seconds of transfer time is allowed per month for any given Lambda function. And then requests, as I told, 1 million requests are free, and then after that each 1 million requests costs you $0.2. And after that duration, I already told you what is GB seconds, so 400,000 GB seconds per month is free, and after that every GB second you use will cost you the number which is given there, that is $0.000166667. So that is all about Lambda pricing.
Today in this session, we are going to discuss the top AWS questions that can be asked to you in your next AWS interview. So we'll start this session by first discussing the domains from which we have collated these questions. These domains are directly mapped to the AWS exam blueprint, which was recently updated in June 2018. So there is a high possibility that your next AWS interview might contain questions from these domains. So I want you to pay the utmost attention that you can so that you can gain as much knowledge as you can from this session. All right, so let's take a top-down approach. Let's start from the simplest questions that are some generic questions on AWS that can be asked to you in an interview. All right. So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? All right, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You're basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity. Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now, you can think of it as, say, you want a deep learning AMI, or you want a Windows Server AMI with specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS marketplace. So the answer for this is AWS marketplace. It's basically a place where you can buy all the AWS systems that you, or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default, or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D, you will not even consider, reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things, wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail, and hence for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload, or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer. Reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says, you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. All right. So the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time, right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are auto-scaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each, and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use elastic cache and in what cases? All right. So the answer for this is basically related to the nature of the service of elastic cache. So elastic cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about a database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an elastic cache, that data can be captured or can be cached inside elastic cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from elastic cache, and that is the exact use of elastic cache, right? So you use elastic cache when you want to increase the performance of your systems, right? Or whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an elastic cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the request to page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Request to page option to access via AWS billing, again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of services of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you're using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right. Let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So this is a simple question. The answer for this is enable multi-factor authentication. So multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay, Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are two types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite. That is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? All right, so to rephrase this question, basically you have an application which has two kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the tasks say should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the back end, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. All right, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. All right, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that a database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. All right. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places.
Okay guys, a quick info. If you want to become a professional AWS Solutions Architect, you can take up this AWS Solutions Architect course provided by Intellipaat. In this course, you will be learning all the concepts which is required to crack the AWS certification exam. And also there are 3 major projects involved for you to understand it better. Okay guys, we have come to the end of this session. I hope this session was informative for you, and if you have any doubts regarding this session, please feel free to comment about it below and we would love to help you out. Thank you.